ಬೇಕಾದ್ರೆ ತೋರಿಸ್ಬಿಟ್ಟಿರ್ತೀನಿ, ಬಂದ್ರೆ ಔಟ್ ಮಾಡ್ಕೊಂಡು ರೆಸ್ಪೆಕ್ಟ್ ಆಗಿ ಮಾಡ್ಬಿಡ್ತೀವಿ ಅಷ್ಟೇ. ನೀವೇ ರಿಮೂವ್ ಮಾಡಿ
ಕಾರ್ತಿ ಯಾರನ್ನೋ ಆಡ್ ಮಾಡ್ಕೊಳ್ಳಿ
ಸರ್. ಅದು ಆಟೋಮೆಟಿಕ್ ಆಡ್ ಆಗೋದು.
ಇಲ್ಲ ಇನ್ನೂ ಇದು ಮಾಡಿಲ್ಲ. ಈಗ ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಸರ್. 20 ಸೆಕೆಂಡ್ ಡಿಲೇ ಇರುತ್ತೆ, ಅದು ಸ್ವಲ್ಪ ಕಡಿಮೆ ಮಾಡಿ. ಎರಡು ಒಟ್ಟಿಗೆ ಇಟ್ಕೊಂಡ್ರೆ ಕೂಡಿದ್ದೀವಿ ಅಷ್ಟೇ.
ಹಲೋ, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಹಲೋ, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಫೋನ್ ಅಲ್ಲೇ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ, ಏನಾಯ್ತು? ಕೋಸ್ಟ್ ಅನ್ನ ಕೊಟ್ಬಿಡಿ, ವಾಸ್ಟ್ ಕೊಟ್ಬಿಡಿ. ಇಬ್ಬರು ಕೊಟ್ಬಿಡಿ
ಸರ್. ಲಾಗಿನ್ ಆಗಿ
ಸರ್, ನಾನು ಮಾತಾಡೋದು ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಇಲ್ಲ. ಹಲೋ ಹಲೋ, ಸರ್ ಕೇಳಿಸುತ್ತೆ ನೋಡಿ ಮಾತಾಡೋದು? ಓಕೆ ಸರ್, 1 2 3 4 ಅಂತ ಕೊಡಿ ಸರ್ ಕೆಳಗಡೆ. ಅದಕ್ಕೆ ಕೆಳಗಡೆ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ಸರ್? ಸುನಿಲ್, ನೀವು ಮಾತಾಡಿ, ಕೇಳುತ್ತಾ ನೋಡೋಣ.
ಅದೇ ನೀವು ಈಗ ಆಪ್ಷನ್ ಕೊಡಬೇಕು. ಫಿಕ್ಸ್ ಮಾಡ್ತಿಲ್ಲ ಮತ್ತೆ ಯಾವ ಸ್ಪೀಕರ್ ಮಾತಾಡ್ತಾರೆ ಮಧ್ಯ ಯಾರು ಮಾಡ್ತಾರೆ ಸ್ಪೀಕರ್ ಮಾತಾಡ್ತಾರೆ. ಈ ದಾಸ್ ಇರುತ್ತೆ ಸರ್, ದಾಸ್ ಆಮೇಲೆ ಒಂದು ಮಾಡ್ತಾರೆ. ಇದನ್ನು ಅಷ್ಟೇ ಕನಕ ತೆಗೆದ್ಬೇಕು.
ಓಕೆ, ಒಬ್ಬರು ಅಡ್ಮಿಟ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ರೇಖಾಶ್ರೀ. ರೇಖಾಶ್ರೀ ನಾನು ಕೊಟ್ಟಿದ್ದೀನಿ. ಅಲ್ಲಿ ಸೌಂಡ್ ಬರಲ್ಲ, ಏನಿಲ್ಲ ಅಲ್ವಾ? ಮಾಡ್ಕೊಳ್ಳಿ, ನೋಡ್ಕೊಳ್ಳಿ ಬೇಕಾದ್ರೆ. ನಿಮ್ಮ ಮೇಲ್ ಐಡಿಯಿಂದನೂ ಆಗ್ಬಿಡ. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲ, ನೀವು ಯೂಟ್ಯೂಬ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಹಾಕೊಳ್ಳಿ. ಅಲ್ಲಿ ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಗೊತ್ತಾಗ್ತದೆ. ಅಪ್ಪ ಸ್ಟ್ರೀಮಿಂಗ್ದು ಕಳ್ಸ್ಬೇಕಾನೆ ಎಲ್ಲರಿಗೂ.
ಸರ್ ಯಾಕೆ 3 ಜನ ಎಲ್ಲ ಸ್ಟ್ರೀಮಿಂಗ್
ಶೇರ್ ಲಿಂಕ್ ತಾನೆ. ರೇಖಾಶ್ರೀ ರೇಖಾಶ್ರೀ MC ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Okay, Rekashri, can you able to hear me? Okay, unmute ಮಾಡ್ಕೊಂಡ್ರಾ?
ಹಾ ಸರ್.
ಇಲ್ಲಿ ವಿಡಿಯೋ ಇಲ್ಲಿ ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ರೇಖಾಶ್ರೀ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಮಾತಾಡ್ತಾ ಇರೋದು? ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಅಲ್ಲ, ಸ್ಟಾರ್ಟಿಂಗ್ ಆಗ್ಬಿಟ್ಟಿದೆ. ಸ್ಟಾಪ್ ಮಾಡಿದ್ರಾ? ಓಕೆ, ರೆಡಿನಾ? ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳಪ್ಪ.
ಕೇಳಿಸ್ತಿದ್ಯಾ ಸರ್?
ಹಾ, ಕೇಳಿಸ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ಎಕ್ಸಾಕ್ಟ್ 11ಗೆ ಇನ್ನೊಂದು 5 ಮಿನಿಟ್ಸ್ ಇರುವಂಗ್ ಲಾಗ್ ಅಂದ್ರೆ ಇರಿ, ಅವಾಗ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿ. ಓಕೆ, ರೆಡಿ ಇದ್ರೆ ತಾನೆ? ನಮ್ದೆಲ್ಲ ವಿಡಿಯೋ ಆಫ್ ಮಾಡ್ಕೊಂಡು ಅಲ್ಲೂ ಆಗ್ತಾ ಇರ್ತಾನೆ ಹೋಸ್ಟ್. ಮಾತಾಡಿ. ಆನ್ ಮಾಡಿ ಕೇಳ್ತೀನಿ ಒಂದ್ಸರಿ. ಸರ್ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಸರ್. ನೋಡಿ ಸರ್ ಇವಾಗ.
It has come. So good morning to one and all. Agatha, is it audible?
ಅವರಿಬ್ರು ಇದು ಮಾಡ್ಕೋಬೇಕು ಸರ್. ಈಗ ಕೋಆರ್ಡಿನೇಟ್ ಮಾಡಿ ವಾಯ್ಸ್ ಫ್ಲೋ ಆಗಿ
ಏನಾಗಿದೆ?
ರೇಡಿಯೋ ತರನೇ ಬರ್ತಿದೆ. ರೇಡಿಯೋ ವಾಯ್ಸ್
ಹೌದಾ? ಅಲ್ಲೆಲ್ಲೂ ಇಲ್ಲ ಪ್ಲಗ್.
Hello, sir. Hello. Hello, sir. This is department. Yes. See, sir, this is that.
ಏಕೆ ಕಳ್ಸಿ ಅಂದ್ರ ಇಲ್ಲ ಇಲ್ಲ ಏನು ಕಳ್ಸಿಲ್ಲ. ಇದು ಲ್ಯಾಪ್ಟಾಪ್ ನ ಅಲ್ಲಿ ಇಟ್ಕೊತೀರಾ?
ಅಲ್ಲೇ ಅಲ್ಲಿ ಆಕ್ಚುಲಿ ಫೋನ್ ಮಾಡಿದ್ದಿಲ್ಲ. ನೀವು ವಾಟ್ಸ್ಆಪ್ ಮಾಡಿ. ಇವ್ರು ನೋಡ್ಬೇಕು ಯಾರು ಈಶ್ವರಪ್ಪ ಮತ್ತೆ
ಎಲ್ಲ ಕಮ್ಮಿ. ಸುನಿಲ್ ನೀವು ಅಲ್ಲ ಇದ್ದೀರಾ? ಯೂಟ್ಯೂಬ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಮಾಡ್ಬಿಡಿ ಅಲ್ಲಿ. ಅಲ್ಲಲ್ಲ ಅಲ್ಲಿ ಯೂಟ್ಯೂಬ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಬಿಟ್ಬಿಟ್ಟು ನೋಡ್ಕೊಬಹುದು ಯೂಟ್ಯೂಬ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಏನಾಗ್ತದೆ ಅಂತ. ಕತ್ತಿ ನಾನು ನೋಡಿ ಮತ್ತೆ ಬರುತ್ತೆ. ಓಕೆ, ರೇಖಾಶ್ರೀ ರೆಡಿ ಇದ್ದೀರಾ?
ಹಾ ಸರ್.
Okay, fine. Okay, dear students, on the small announcement. So, Madhya, the resource persons ಮಾತಾಡ್ಬೇಕಾದ್ರೆ ತಮ್ಗೆ ಏನಾದ್ರು queries ಇದ್ರೆ, so ಅದನ್ನ ನೀವು ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಅದನ್ನ ಟೈಪ್ ಮಾಡಿ ಕಳಿಸಿದ್ರೆ ನಾವು ಅದು ಕ್ವಶನ್ಸ್ ಅನ್ನ ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ ಗೆ ಕೇಳ್ತೀವಿ. ಸೊ ದಿ ಡೌಟ್ ಕ್ಯಾನ್ ಬಿ ಕ್ಲಾರಿಫೈಡ್. ಸೊ ಮಧ್ಯೆ ಯಾವುದೇ ತರದ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಯಾವುದನ್ನು ಏನು ಮಾಡೋದಕ್ಕೆ ಹೋಗ್ಬೇಡಿ. ಇಟ್ಸ್ ಎ ಕೈಂಡ್ ರಿಕ್ವೆಸ್ಟ್ ಫ್ರಮ್ ಅವರ್ ಸೈಡ್. ಹಲೋ ಹಲೋ ಹಲೋ, ಇನ್ನು ಕೆಲವು ನಿಮಿಷಗಳಲ್ಲಿ ಪ್ರೋಗ್ರಾಮ್ ಶುರು ಆಗುತ್ತೆ.
ಆಗಿದೆ. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಹಲೋ, ನಾನು ಮಾತಾಡೋದು ನನಗೆ ಕೇಳಿಸಲ್ವಾ? ನನಗೆ ಕೇಳಿಸಲ್ಲ. ಹೌದಾ? ಹಲೋ, ಮಾತಾಡಿ ವಿನಯ್.
ಹಾ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
ಹಾ, ಕೇಳಿಸ್ತಾ ಇದೆ. ಯಾಕೆ ಈಶ್ವರಪ್ಪನವರಿಂದ ಫೋನ್ ಮಾಡಲ? ಬಂದಿದ್ದಾರ? ಎಲ್ಲಿದ್ದಾರೆ? ಈಶ್ವರಪ್ಪನವ್ರಿಗೆ ನಮಸ್ಕಾರ ಸರ್. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ
ಸರ್? ಕೇಳಿಸ್ತಾ ಇದೆ. ನನ್ನ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್?
ಹೌದು ಹೌದು ಹೌದು.
ವಾಯ್ಸ್ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್?
ಕ್ಲಿಯರ್ ಇದೆ ಸರ್.
ಓಕೆ.
ಈಗ ನಾನು ಮಾತಾಡೋದು ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಸರ್?
ಸರ್ ಕ್ಲಿಯರ್ ಇದೆ.
ಓಕೆ. ಡಾಕ್ಟರ್ ಕಂಸಾಲಿ ನಾಗರಾಜ್ ಅವರು ಲೇಟಾಗಿ ಜಾಯ್ನ್ ಆಗ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ.
ಸರ್ ಫೋನ್ ಮಾಡಿದ್ರು ಸರ್, ಮಾಡಿದ್ರು.
ಅವ್ರದ್ದು ಪಾಪ ಏನೋ ರೆಗ್ಯುಲರ್ ಅಕಾಡೆಮಿಕ್ ವರ್ಕ್ ಇದೆ, ನಾನು ಅರೌಂಡ್ 11:45 ಏನೋ ಜಾಯ್ನ್ ಆಗ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ.
ಓಕೆ ಇರ್ಲಿ ಸರ್. ಈಗ ನಂದು ಟೈಮ್ ಎಷ್ಟಿಂದ ಎಲ್ಲಿವರೆಗೆ ಸರ್?
1 hour ಡ್ಯೂರೇಷನ್ ಈಶ್ವರಪ್ಪನವ್ರೆ. ಅದರಲ್ಲಿ ಕ್ವಶನ್ಸ್ ಅಥವಾ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಒಂದು ಲಾಸ್ಟ್ 5-10 minutes ಇರುತ್ತೆ.
ಓಕೆ ಸರ್. ಮೈ ಟಾರ್ಗೆಟ್ 12 o'clock ಅಲ್ವಾ ಸರ್?
11 ನನ್ನ ನಂತರ 45 minutes ಅಥವಾ 50 minutes ಇದೆ.
ಓಕೆ ಸರ್.
ಏನು ನಾವು ವಿ ವಿಲ್ ಗಿವ್ ಯು ದಿ ಡಯಾಸ್. ಯು ಕ್ಯಾನ್ ಸ್ಟಾರ್ಟ್ ಸ್ಪೀಕಿಂಗ್ ಟು ಆಡಿಯನ್ಸ್ ಓನ್ಲಿ ಆಫ್ಟರ್ ದಿ ಬಿಗಿನಿಂಗ್. ಒಂದು ಬಿಗಿನಿಂಗ್ ಇದೆ, ಇಂಟ್ರೊಡಕ್ಷನ್ ಮತ್ತೆ ವೆಲ್ಕಮ್ ಆದ್ಮೇಲೆ ನಿಮಗೆ ಬರುತ್ತೆ.
ಶೋರ್.
ಥ್ಯಾಂಕ್ ಯು. ವಿನಯ್, ಟೈಮ್ ನೋಡಿ. 4 ನಿಮಿಷ ಇದೆ ವಿನಯ್.
ಹಾ ಸರ್.
ಈಶ್ವರಪ್ಪನವ್ರೆ ಪ್ರಾರಂಭ ಮಾಡೋಣ.
ಹಾ ಸರ್, ಆಸ್ ಯು ವಿಶ್ ಸರ್. ಇನ್ನು ನಾವು ವೇಟ್ ಮಾಡೋದಾದ್ರೆ ಇನ್ನೂ 4 ಮಿನಿಟ್ ಇದೆ.
ಬರ್ತಾರೆ.
Okay.
The thing is, early it was 100 and the others has to attend through YouTube link.
Oh,
Now
okay,
it
okay.
is telling that it is extended to more than 100, around 200 or 300.
Okay, okay.
So we will see to it. Idea, Karthik? Link ಕೊಡ್ಬೋದಾ? ಎಲ್ರಿಗೂ ಮಾಡಿದ್ದೀರಾ? ಓಕೆ, ಈಶ್ವರಪ್ಪನವರೇ ಪ್ರಾರಂಭ ಮಾಡೋಣ.
ಆಯ್ತು ಸರ್, ಆಯ್ತು.
ವಿನಯ್ ಕುಮಾರ್.
ಸೊ ಎಲ್ಲರಿಗೂ ಬೆಳಗಿನ ಶುಭೋದಯ. A very good morning to one and all. At the outset, I pay my respects to the Guru Parampara of Sri Suttur Mutt. I offer my respectful pranams to His Holiness Jagadguru Dr. Sri Shivaratri Rajendra Mahaswamiji, the founder president of JSS Mahavidyapita. And also I submit my salutations to the lotus feet of His Holiness Jagadguru Sri Shivaratri Deshikendra Mahaswamiji, president of JSS Mahavidyapita. So now let us begin the program with an invocation song by Rekashri, a BSc student. Over to you, Rekashri. So please unmute.
ಮೊದಲಿಗೆ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಸರಿ ಮಾ ಗರಿ ಸರಿ ಗರಿ ಸ ರೀ ಮ ಪದ ಮ ಪ ದ ಪ ಮ ಗರಿ ಸ ಸರಿ ಮಾ ಗರಿ ಸರಿ ಗರಿ ಸ ಲಂಬೋದರ ಲಕುಮಿಕರ ಅಂಬಾಸುತ ಅಮರ ವಿನೂತ ಲಂಬೋದರ ಲಕುಮಿಕರ ಅಂಬಾಸುತ ಅಮರ ವಿನೂತ ಲಂಬೋದರ ಲಕುಮಿಕರ ಶ್ರೀ ಗಣನಾಥ ಸಿಂಧೂರ ವರ್ಣ ಕರುಣ ಸಾಗರ ಕರಿವದನ ಲಂಬೋದರ ಲಕುಮಿಕರ ಸಿದ್ಧಚಾರಣ ಗಣ ಸೇವಿತ ಸಿದ್ಧಿ ವಿನಾಯಕ ತೇ ನಮೋ ನಮೋ ಲಂಬೋದರ ಲಕುಮಿಕರ ಅಂಬಾಸುತ ಅಮರ ವಿನೂತ ಲಂಬೋದರ ಲಕುಮಿಕರ. ಧನ್ಯವಾದಗಳು.
Thank you, Rekashri. So now I request Dr. Vijay Manjunath Guru to welcome the gatherers for this seminar. Over to you, sir.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. A very good morning to one and all. At the outset, I pay my respects to the Guru Parampara of Sri Suttur Mutt. I offer my respectful pranams to His Holiness Jagadguru Dr. Sri Shivaratri Rajendra Mahaswamiji, the founder president of JSS Mahavidyapita, and I submit my salutations to the lotus feet of His Holiness Jagadguru Sri Shivaratri Deshikendra Mahaswamiji, president of JSS Mahavidyapita. Distinguished Professor B.V. Sambashivaya sir, Chief Executive JSS College, Dr. H.C. Vannappa, Principal, resource persons of the webinar, invitees, faculty members, delegates, students, and all other present in the webinar. For the information of the guests and other invitees, I would like to say a few words about our college. JSS College of Arts, Commerce and Science, established at Mysore in the year 1964, is a multi-faculty, co-educational, grant-in-aid college affiliated to University of Mysore and is re-accredited by NAAC with A grade, recognized by UGC as college with potential for excellence. At present, the college is offering 15 PG programs, 7 UG programs with 21 combinations, 30 COC courses, 9 PhD programs, and UGC and Government of Karnataka sponsored innovative and research-oriented PG diploma programs, along with vocational educational programs, BVOC and MVOC. On 29th August 2021, JSS Community Radio Station 91.2 FM was inaugurated and is broadcasting its programs. It's vital to say that all these have been made possible due to the blessings of His Holiness Jagadguru Sri Shivaratri Deshikendra Mahaswamiji and unstinted support of JSS Mahavidyapita and all the stakeholders. I am proud to say that the college has emerged as one of the best colleges in the state. This webinar is organized by the Department of Physics with the objective to create a forum to disseminate the current trends, opportunities, and major outcomes in the field of nuclear and astrophysics, especially for students community. As far as the current trends in astrophysics, there has been dramatic process in exploring cosmos in the last decade. Highlights include close-up studies of the planets and moons of our solar system, the realization that most stars are orbited by planets and that there may be millions of Earth-like planets in our galaxy. On a still larger scale, we have achieved a better understanding of how galaxies have developed. Einstein's theory received further confirmation with the detection of gravitational waves. Future advances will depend on more powerful instruments, which could reveal evidences on life on exoplanets and yield a better understanding of Big Bang and the ultimate facts of our cosmos. Today, astronomy is an enterprise that involves a huge range of disciplines, mathematics, physics, and engineering, of course, many others too. Astronomers aim to map and survey various entities, planets, stars, galaxies, black holes, and so forth that pervade the cosmos. A more ambitious aim is to understand how the entire cosmos panorama, of which we are a part, emerged from our universe at dense beginning. The pace of advance has crescendoed rather than slackened. Instrumentation and computer power have improved hugely and rapidly. The last decade, in particular, has witnessed some astonishing advances, and the promise for the future is even brighter. Astronomy offers splendid opportunities for young researchers who want to enter into vibrant field. Nuclear physics is an important pursuit because the study of nucleus of the atom is at the heart of our ability to understand the universe, and that these particles form a complex system that makes it possible for us, our world, and our visible universe to exist. Nuclear physics continues to have a profound impact on the production of energy. Nuclear fission reactors produce about 19% of US electricity, 17% worldwide, and they provide an option for reducing use of finite hydrocarbon fuels and hence the emission of carbon dioxide into the atmosphere. Nuclear physics principles have led to groundbreaking medical diagnostics and therapy methods. In addition to diagnosing and treating cancer, nuclear medicine processes are used to detect Alzheimer's disease, treat hyperthyroidism, and evaluate coronary artery disease. About 40% of nuclear engineers work in the industry of electrical power generation. For academic research jobs, nuclear physics may well be a better choice, while the opportunity to design real-world solutions to power generation and medical problems is a major benefit of studying nuclear engineering. The current trends in nuclear physics, there are investigations in 3 broad directions: the behavior of hot and high-density nuclear matter, nuclear force in terms of quarks and gluons, and nuclei away from the line of stability. With this, I am really privileged to have pleasant task of welcoming the guests invitees and others to this webinar program. Professor B.V. Sambashivaya, former grade 1 principal, has served this college nearly a decade and now the executive of the college since 2013. Professor Sambashivaya has been actively engaged in various administrative and academic activities for the overall development of the college. As said earlier, we are all witnessing the college as one of the best due to his commitment and support. It is my privilege to extend a warm welcome to you, sir. It is my privilege to extend a warm welcome to Dr. H.C. Vannappa, sir, to the webinar. On behalf of the college, I extend a warm welcome to the resource person, Dr. Ishwarappa, Associate Professor, Davangere University, and Dr. Kamsali Nagaraja, Associate Professor, Bangalore University. On behalf of the college, I extend a warm welcome to invitees, faculty members, delegates, students, and all others present in the webinar. I hope this webinar will be a wonderful opportunity for all of you. Thank you very much.
Thank you, sir. It's my privilege to welcome Dr. Vijay Manjunath Guru for this one-day state-level webinar on the behalf of JSS College and myself. Welcome you, sir.
Thank you, sir.
So now, it's my great pleasure to introduce today's speaker, resource person, Dr. K.M. Ishwarappa, sir. So Dr. K.M. Ishwarappa, Associate Professor, Davangere University, obtained his MSc in Physics from Coimbatore University in the year 1997, MTech in Computer Science and Technology from Mysore University, and PhD in Physics from Mangalore University in 2008, and also qualified CSIR UGC NET. Dr. K.M. Ishwarappa was worked as lecturer in the Department of PG Studies and Research in Physics, Coimbatore University from July 1997 to November 2000. So Assistant Professor of Physics, Government Science College, Asan from July 2006 to May 2019. Presently, he is working as Associate Professor, Department of Studies in Physics, Davangere University, Davangere from 1/6/2019 onwards. So Dr. K.M. Ishwarappa has got 29 research paper publications in international journals and 12 in conference proceedings. He is the recipient of Research Fund for Talented Teachers, VGST, Government of Karnataka. He has received the Best Paper Presentation Award at International Conference on Recent Advance in Physics for Interdisciplinary Developments, held at Satyabama University, Chennai, during January 2014, and Best Paper Award in National Seminar on Quality Assurance and Quality Sustenance in Higher Education Institution, Challenges and Issues. So organized by Government Science College, Asan. So from 1st March 2016. He has designed, fabricated, and characterized the microtron-based photoneutron source and neutron radiography assembly installed at Microtron Center, Mangalore University, in collaboration with Baba Atomic Research Center, Bar, Mumbai. India, which is first of its kind in the country, it was formally commissioned by former Atomic Energy Commissioner, Dr. M.R. Srinivasan, sir. So Dr. K.M. Ishwarappa is editorial board member, Nuclear Science Publishing Group. So reviewer for Elsewhere Publication Journal, Annals of Nuclear Energy, reviewer for Springer Publication Journal, Nuclear Science and Techniques. So Dr. K.M. Ishwarappa is serving as member of Board of Studies in Reva University, Bangalore City University, Bangalore. So on behalf of the college, I wholeheartedly welcome Dr. K.M. Ishwarappa to this webinar. Welcome you, sir, and over to you, sir.
Thank you very much, Dr. Vinay, for a nice introduction. Am I audible?
Audible, sir.
Okay, thank you very much. So first of all, let me offer my pranam to the Suttur Mat Swamiji, and also my salutation to the Suttur Mat Swamiji. And let me express my sincere thanks to the organizers for being invited on this beautiful occasion, state level webinar. I heard that many of the audience are MSc students, and also some faculties are there. So I thought to going a little bit fundamental also about the radiation shielding, and then later I will be discussing on some few examples of recent developments in the radiation shielding material, so that the participants, younger participants, particularly the MSc students, will have a very clear idea of how to develop in a new shielding material. So if you go through the fundamentals very clearly. So let me share. Dr. Binay, is this enabled? Screen
Yes, sir.
share?
Yes, sir, it has enabled.
Okay, so I will go through that. Let me share this slide. Okay. The slides are visible to you?
Yes, sir, it's visible.
Okay. Okay, right. So as I was discussing with Professor Manjunatha Guru sir, he asked me to speak on some recent developments in nuclear physics. So recent developments in nuclear physics is a very, very vast area, as it's very difficult to pinpoint what exactly we need to speak. And then I discussed with Manjunatha Guru sir, so I will going to talk on this the recent developments in shielding materials. Then, okay, agreed. Then I just started working on that. So we know that why a lot of work. So these are the days where a lot of work is going on the nano. So everybody is, wherever you go, everybody is telling that I am working on the nano development of nanomaterial, development of the nano devices, things like that. There are only few people are working in particularly the nuclear science and technology. So even this scenario is not only prevailing in India, it's everywhere all through the world, as of my knowledge is concerned. Only few people are working in this sector. It's mainly because of the vast, newer and newer applications are coming out of this nanoscience. It's natural to that people to switch over in that particular area. Anyway, nevertheless, what we are discussing today is that I'm going to discuss what are some of the fundamentals things which one should know in order to develop a radiation shielding material. So based on that, how one can develop a new and novel shielding materials, right? So what is the necessity of developing a shielding material? So you know that gamma emitting radionuclides are found useful in many fields, like industry, medical fields, agriculture. Everywhere we are using the gamma emitting nuclides because of the applications of these gamma radiations. And obviously the gamma emitting nuclides are the source for these gamma radiations, and people have been employing these radiation to their applications. We know that these gamma radiations are electromagnetic radiation. They can easily transmit through the thick wall because of the high penetration power. They can easily penetrate through the thick wall. So which leads to the greater occupational exposure in a nuclear facility if they are not shielded properly. So using a suitable shielding material, one can ensure the safety of the radiation workers against this harmful radiation. So consequently, many researchers have been paid a great effort to develop and design a well-formed radiation shielding material. In this way, a range of materials include concrete, the very preliminary the shielding material which have been employing even till today, also being used, concrete, lead oxide, lead and lead oxide based shielding materials, and also some oxide glasses have been developed to shield the radiations. So the concrete obviously been formed from a loosely compacted mass of small fragments or particles. It has several limitations to be used as a shielding in a nuclear reactor. And particularly is when it comes to the shielding in an other than nuclear reactor facilities, the concrete shielding is somewhat difficult due to it. Mainly it is because due to its non-transparent characteristic. It is not possible to observe or monitor the internal environment. Moreover, the variation in water quantity in the concrete often exhibits unwanted fluctuation in the attenuation coefficients, right? So to overcome such limitations, people have developed several glass-based materials. And being transparent, these glass-based materials are being transparent in visible light, their properties can be modified, changing the components and preparation methods. As a result, a number of researchers have studied the gamma ray attenuation properties for varieties of glasses, like bismuth borate glasses, like lead borate glasses, lead fluoroborate glasses, bismuth borosilicate glasses, alkali borosilicate glasses, borium silicates, like that. The various types of glasses people have studied. So before going to the what exactly the recent development in the radiation shielding, development in the materials which are going to employ for the radiation shielding. So now I will just concentrate on some of the fundamental aspects of gamma ray attenuations, how one can actually what is the basic physics of the gamma ray shielding. So all of you have studied and you might have done the experiment of gamma ray attenuations in, for example, in copper. In your BSc or MSc experiments, you might have done this experiment, studying the gamma ray attenuation in a copper or aluminum or things like that. Here, say when a beam of gamma ray of intensity I0 passes through a material or observable in general, it may be of anything. So it may be metal or a compound or whatever it may be. When it passes through that, it attenuates the beam. And suppose if the outcoming beam intensity is I, then it is this I0 and I are related by a well-known Beer-Lambert's law. That is I is equal to I0 into e power minus mu x, where mu is the linear attenuation coefficient. See here, so while this is very simple picture, what exactly the physics, what exactly these gamma ray interact with matter. All of you know that this gamma ray interact with the matter by three important phenomena. One is photoelectric effect, second one the Compton scattering, and the third one is the pair productions. All these processes are contributing for the attenuations, provided so the means the one effect will be dominant over the other. It all depends upon the energy of the gamma radiations, right? And also it depends upon the Z value of the observer, atomic number of the observer, right? So for example, see, this photoelectric effect is dominant in the low energy range regime, so less than 500 electron volt, 500 kV, and Compton scattering is dominant above that 500 kV, and pair production is dominant in the energy range above 1.02 MeV, mega electron volt, right? See, this particular picture gives the relative importance of the various processes of gamma radiation interaction with the matter. So depending upon the gamma energy and the absorber material, so one of the partial cross-section may become much larger than the other. See, the cross-section, as you know, the cross-section means it's the probability of that particular interaction take place. It gives the cross-section is a measure of probability of the particular interaction take place. If I say the photoelectric cross absorption means absorption cross-section means it's what is the probability that photoelectric absorption take place. And similarly, Compton scattering and pair productions, it's a measure of the probability of that particular interaction take place. And of course, at small values of gamma energy, small values of gamma energy, the photoelectric dominates. This particular picture clearly tells the relative importance of various processes. And Compton scattering dominates at intermediate energy, And of course, this Compton scattering also increases with the decreasing atomic number. Therefore, the interval of domination is wider over a lighter nucleus. So x-axis is an atomic number. So we can see this is at the lower atomic number, this interval is very, very wide. So which means that Compton scattering also increases with the decreasing atomic number. And finally, the electron-positron pair production dominates at very high energy, which inset after say 1.02 MeV. Right. So the based on the definition of the interaction cross-section, I mean the cross-section, the dependence of gamma ray intensity and the thickness of the observed material can be derived. Suppose if the monoenergetic gamma rays are collimated into a narrow beam, if the detector behind the material detects the gamma rays that passes through the material without any kind of interaction with this material, then the dependence should be simply exponential. As I mentioned earlier, I is equal to I naught e power minus mu x. And each of these interactions removes the photon from a beam either by absorption or by scattering away from the detected direction. Therefore, interaction can be characterized by a fixed probability of occurrence per unit path length. The sum of these probabilities is called the linear attenuation coefficient. I mean, what is the probability that the particular rays undergoes photoelectric effect? The corresponding probability, the tau, and the sigma attenuation coefficient corresponds to the Compton scattering, is denoted by sigma, and plus k the production. So total linear attenuation coefficient is the sum of the probabilities, these probabilities that corresponds to photoelectric effect, Compton scattering, and the pair productions. So, okay, these are the some little bit the basics of physics of that. Now, what are the parameter we use? We usually come across during the development of a shielding material, or development of the shielding material, or design of a shielding for a particular facility. So, some of the important parameter we used to look after are linear attenuation coefficient, mass attenuation coefficient, mean free path, right? And off-valley layer, radiation protection efficiency, the exposure build-up factor, and energy absorption build-up factor. These are all the various factors. So we will be using in order to design a particular radiation shielding for a particular facility. So let us go one by one very quickly. See, as I mentioned in our earlier experiment, earlier discussion, while discussing the gamma ray attenuation, the attenuation of gamma ray radiation can be described using the equation I is equal to I naught e power minus mu x, where I the intensity after attenuation, I naught is the incident intensity, mu is the linear attenuation coefficient. It is, as I said, it's a sum of the probabilities of all the processes, photoelectric effect, pair production, and Compton scattering, and x is the physical thickness of the absorber. So there are two main features of the linear attenuation coefficient. What are these? The linear attenuation coefficient increases as the atomic number of the observer increases. And also the linear attenuation coefficient for all materials decreases with energy of the gamma rays. These are the two important things one should keep in the mind while designing the radiation shielding. The term which we need to know is mass attenuation coefficient. When characterizing an absorbing material or when characterizing the shielding material, so we can use sometimes the mass attenuation coefficient, because the mass attenuation coefficient is defined as the ratio of linear attenuation coefficient and observer density. That is mu m is equal to mu by rho. So now if you substitute mu by rho into the earlier expression, I is equal to I naught into e power mu x. So here mu by rho is then a linear attenuation coefficient. and rho into T, the mass thickness or a density thickness. That is why, and the corresponding dimension or measurement unit for the mass attenuation coefficient is centimeter square per gram. And the third, see here, suppose for intermediate energies, the Compton scattering dominates, as I told you. The absorber have a approximately equal mass attenuation coefficient. This is due to the fact that the cross-section for Compton scattering is proportional to Z, and therefore coefficient is proportional to the material density. See, why I'm mentioning here is that if there are species in your material, so if you're having only the single Z material, it's not a problem. Suppose if you are using mixtures or compounds, then so we need to know what is the relative effects of these various processes. See, at intermediate energies, Compton scattering dominates. I mean, above 500 kV, it dominates. And its cross-section is proportional to Z, the first power of the Z. And therefore, the coefficient is inversely proportional to the material density, obviously. So the mu by rho is almost constant for a different material for this Compton scattering, right? And at small values of gamma energy, means very low energy, less than 500 kilo electron volt. Even at very high values of gamma energy, like above 1.02 energy, the coefficient is proportional to the higher powers of the atomic number. We know that the cross-section, photoelectric cross-section, absorption cross-section of a material is proportional to the fifth power of the Z. Whereas for plate production, the attenuation coefficient is cross-section is proportional to the square of the atomic number. I mean, square of the Z. So in that case, we can suppose if it is a mixture, whatever the material you are using is a mixture, then we can use the mixture rule to determine the mass attenuation coefficient. The mixture rule is the mu m is equal to sigma of Wi and mu m I. So here Wi is the corresponding weight percentage of the corresponding species. For example, a simple example is sodium chloride. If you want to know what is the attenuation coefficient of sodium chloride, so we need to know what is the percentage of sodium in a sodium chloride, weight percent, and what is the weight percent of the chloride in a sodium chloride, and the corresponding attenuation coefficient. Multiply with the corresponding weight fraction and take the sum of those two products, you'll get the total mass attenuation coefficient of that particular compound. Similarly, if it is a more than 1, 2, 3, so we need to use this mixture rule to get the corresponding mass attenuation coefficient. The next important term is we are talking while designing the shielding material is mean free path. The mean free path is defined as average distance traveled by the photon before being absorbed in a particular material. And it's calculated as mean free path. Lambda is equal to 1 over attenuation, linear attenuation coefficient, or mu inverse. Right? So if you take the inverse of the linear attenuation coefficient, so you will get what is known as mean free path. Next, very important terms we are encountering during this shielding design, or the off-value layer or off-value thickness of an absorber. It is defined as material thickness to diminish the intensity I to be I2 I naught by 2 or 0.5 I naught. So it is the thickness of the material to reduce the intensity of its initial intensity. HVL, half value layer, is equal to 0.693 divided by mu, or 0.693 to mu inverse. So it is something like your half-value, half-life of a radioactive, like that. I have used the expressions, so yeah, that you can work out very easily. See here, the off-value value layer decreases as the atomic number of the observer increases. For example, if a 35 meter of air is needed to reduce the intensity of 100 kilo electron volt gamma ray beam by a factor of 2, whereas just 0.12 millimeter of lead can do the same thing, right? So 0.12 mm of lead can do the same thing what the 35 meter of air can do to reduce the intensity of the 100 kV gamma ray. And off layer for all the material increases with the energy of the gamma rays. It increases as the energy of the gamma ray is also increases. For example, 0.26 centimeter of iron at 100 kV to about 1.06 centimeter at 500 kV. I mean, 500 kilo electron volt to gamma ray, we need the 1.06 centimeter for iron to reduce, right? To reduce its initial intensity to half of, to reduce the initial intensity to half of its value. Similarly, the one more term we are using is the radiation protection efficiency. The radiation protection efficiency of an attenuator of any absorber you can determine using the following equation, that is RPE, radiation protection, the 1 minus of e power minus mu t into 100. So e power minus mu t as usual, it gives the intensity after traveling through a certain absorber thickness t, and 1 minus of that into 100 it gives the what is the corresponding radiation protection efficiency in terms of percentage. So now, whatever we have discussed, how long this exponential law valid? I mean, I is equal to I naught into e power minus mu x or mu t. So how long it valid? See, exponential law always describe the attenuation of the primary radiation by matter. Whatever, it describes the attenuation of primary radiations. If secondary particles are produced, or if the primary radiation changes energy or direction, then the effective attenuation will be much less, right? The radiation will penetrate more deeply into the matter than predicted by the exponential as a result of the production of the secondary radiation. So the radiation will penetrate more deeply into the matter than it is predicted by exponential law. So we need to take this into account while evaluating the shielding material. I mean, while designing the radiation shielding material, we need to take into account the production of secondary radiation. That I think this figure, picture, though it's not clear, so I will just mention. See, the primary particles go on decreasing. The x-axis is the material depth, and y-axis is the number of particles. Starts from 0 to 50, 500, 750, like that. And thickness is 0, 100, and 200, 300 mm, right? So the primary particle intensity go on decreasing as the depth increases. And the secondary particles, whatever the secondary particles produced while traveling through this or while interacting with the material in which they are passing, this increases, right? This increases the depth, and also it becomes almost saturated. After certain depth, the intensity becomes saturations, and number of secondary particles production becomes saturation. See, here, if you don't consider the production of secondary particles, so I think we're going to fail in protection, protection from the radiations. So while designing any shielding, we need to take care of this production of the secondary particles. For that, we're going to employ what is known as a build-up factor in order to consider the production of the secondary radiation in shielding. So we need to talk about the build-up factor. Build-up factor is an important parameter in distribution of photon flux in every object. Build-up factor is a correction factor that considers the influence of the scattered radiation plus any secondary particles in the medium during shielding calculations. If we want to account for the buildup of secondary radiation, then we have to include the buildup factor. So buildup factor is then a multiplicative factor. It's a multiplicative factor which accounts for the response to the uncollided or unscattered photon so as to include the contribution of the scattered photons. Therefore, buildup factor is defined as the ratio of the total detector response to that of unscattered photons. See here, the buildup factor is the very basic requirement for the shielding calculations. It's been classified into two categories. One is energy absorption buildup factor, EABF, and exposure buildup factor. Energy absorption buildup factor is the buildup factor in which the quantity of interest is the absorbed or deposited energy in the interacting material. Here the quantity of interest is the energy, deposited energy or absorbed energy in the material. And the detector response function is that of absorption in the interacting material. Here the detector response function is that of absorption in the interacting material. Whereas in the case of EBF, I mean exposure buildup factor, the quantity of interest in the exposure, right? Whereas in the EABF is the quantity of interest in the absorption or a deposit of energy in the interacting material. Whereas in the EBF, the quantity of interest in the exposure, whereas the detector response function corresponds to that of the absorption in the air. And this means there is an assumption that exposure is equivalent to the absorbed dose in air as measured by the non-perturbing detector. So these are the two important quantities, the energy absorption buildup factor and exposure buildup factor. One needs to take care while designing the shielding material. Suppose, as I told you, I wanted to design the shielding in the form of some mixtures, a mixture of elements or compounds. Then one need to know about what is the fractional abundance of each species in the mixture or a compound, and the corresponding atomic mass and the atomic weight, so which can be used to calculate the what is the probability. See, we're going to use the two quantities. So one is what is known as total atomic cross section, and also total electronic cross section. Here the total electronic cross section is equal to the summations of Fi, I mean fractional abundance of the particular species, and Ai, I mean atomic mass, and the corresponding mass attenuation coefficient divided by the corresponding Z and the Avogadro number. So the calculated quantities, the total atomic cross section and total electronic cross section, can be utilized to calculate the Z effective. Okay, 1 minute. So this Z effective is the ratio of, I think I have misses some slide here. It's a Z effective. So if you know the total atomic cross section and molecular cross section, whatever it may be, we take the ratio of this total atomic cross section to the corresponding electronic cross section. What you will get is a Z effective Z value. If the material is composed of various elements, then one has to find what is the effective Z, right? So that we can find by the ratio of the total electronic cross section to that of the total atomic cross section. Then you will get what is known as a Z effective. So these are all the various fundamental things. So one has to clearly work out to calculate while designing the particular, while developing the shielding material and also designing the shielding material. So with this, I'm going to a particular shielding material. which are being developed recently to overcome the limitations of the shielding material based on lead. Right, as you know, the lead is a very toxic element and it's a very heavy element. So these lead-based shielding material cannot be employed everywhere. Right. For example, see, suppose the higher altitude where, for example, flight attendants, so where they're constantly being exposed to the higher energy radiations, where it is absolutely over for them to use the lead-based shielding, as we are seeing in the case of hospitals, where people have used that a thin sheet of lead-based shielding, which is very heavy, and in fact it's a toxic also. That type of shielding is not suitable for some of the applications. You know, so as I mentioned, nowadays everywhere people have been using this nanotechnology, and people here also using the nanotechnology. Based on this nanomaterials, people have developed nano composites for radiation shielding. Right. So yeah, because these the polymer nanocomposites are having some outstanding special physical and mechanical features just by adding a small amount of nano particles. Polymer composites filled with the nano scale metal oxides are good candidates for shielding the gamma radiations, especially for diagnostic X-rays below 150 kilovolt. Right. These composites are combining a matrix part, the polymer part, it's a matrix, and a reinforcement phase. The polymers are lightweighted, non-toxic, and flexible materials. And the chief advantage of using the polymer is their ability to process quickly and their excellent chemical resistance. However, as they have low atomic number, they cannot be used as a gamma radiation shields. As I mentioned earlier, the gamma radiation attenuation is highly dependent on the Z value of the absorber. Since these polymers in the polymer composites are low Z materials, so that is why we are using this polymer as a matrix in which we are going to fill some IZ nanomaterial. Mostly the compound azimuth IZ and high density is added as a reinforcement phase to enhance the gamma attenuation. Polymer composites have a hydrogen-rich organic polymeric material at the matrix, which has an effective role in absorbing the neutrons also when using the shields, because the neutrons attenuation of neutrons are somewhat quite different compared to the gamma radiation. These neutrons are highly attenuated by low Z material compared to the high Z material. Hence, these polymer composites can also be used as a shielding for neutrons, as these polymers are made up of low Z materials. So as a result of this property of these polymer composites, secondary radiations like Bemshalang produced in the presence of IZ metallic shields such as lead bismuth is reduced. So since we are not using this IZ material in this polymer like lead or bismuth, where we can avoid this secondary radiation, production of secondary radiation in the form of Bemshalang. In addition, it also reduces the effective weight of the shielding material, as where mainly the polymers are very lightweight and only few percent of the this composite is consisting of an high Z nano material. So it effectively its weight will be very less compared to the lead-based shielding material. Recently, there's an attention in the effects of presence of nanoparticle in the shielding material due to the novel utility. As you know, the nanomaterials are having the very interesting property they exhibit at a nanoscale. The two main factors that bring about the different behavior in the nano and microparticles are quantum effects and an increase in the surface to volume ratio factor in nanoparticles. These parameters affect the mechanical, thermal, and also the shielding properties of the material. It is well known that dispersion of the nanoparticles into the polymer matrix is much more challenging than micro-sized particles due to the high surface area induced agglomeration. So these are all some of the practical difficulties we encounter during the fabrication of the polymer nanocomposites based shielding materials because of the dispersion of nanoparticle into the polymer matrix. So we need to take a lot of care, and we need to disperse properly so that we'll get a uniform distribution throughout the polymer matrix. So according to the prominent features of the nanoscale particles than microparticle, it's causing an impressive increase in the attenuation coefficient. And it's all the studies also shows that combining the two phases of the matrix, the polymer matrix and the reinforced matrix, here the reinforcement is then mainly the nanoparticle dispersion. And suppose we can also study separately the attenuations, gamma interactions in separately, and then you can combine. So then we can get the clear-cut idea of how effective this polymer composite for the radiation shielding. See, the polymers have amorphous structures like polycarbonate, polystyrene, or so obviously they are the better choice for making a homogeneous nanocomposites. The crystalline polymers are not good for the polymer composite shielding materials. Only the polymers which have the polymer structures are better to choose for this polymer composite shielding materials. The IZ materials that have been considered as alternative for lead and have nearly the same effects on shielding radiations are mainly the high density with a high atomic number. We wanted to, our main intention is to develop a non-lead based polymer nanocomposite. Again, mainly because of the toxicity of the lead and other things. So people are looking for a non-toxic shielding materials. For that, so like the tungsten oxide is a non-toxic, bismuth oxide, barite. So all these are materials are non-toxic, so that so one looking for these material-based polymer composites. So here the polymer acts as a matrix, and in which these IZ materials are dispersed so that you will have an effective shielding material. See, the following table shows that the sum of linear attenuation coefficient for 200 kilo electron gamma rays. See, for example, if you use the lead is having the density 11.34, whereas bismuth oxide 8.9, tungsten oxide 7.6, barite, though its the density is less, but the linear attenuation coefficient is almost comparable. The bismuth, especially the bismuth oxide, is incomparable. One more advantage we can relax with that of the attenuation coefficient is that of a non-toxic nature. Right, is non-toxic nature the much more critical issue. One has to look into that. So because of that non-toxic nature of these materials, so the people are nowadays interested and to develop a non-lead based shielding materials. So here the reinforcement like these bismuth oxide, tungsten oxides are adding to the polymer oxide initially, and then distribute all over the polymer when they start crystallization, they will be refused by the crystal parts and indwell in an amorphous part of the polymer. So that is why I told you that it is crucial to select the polymer that is its structure is mostly amorphous than a crystalline. Amorphous tends to have a better dimensional stability and impact resistance, right, than the crystalline polymer. Therefore, so in this type of research, a polycarbonate with a density of 1.2 gram per centimeter cube, generally they use the matrix for nanocomposites. I'm just mentioning the particular work which has been carried out recently and which is published in the Nature by some Chinese group. they actually developed this kind of materials for radiation shielding. And here the polycarbonate as an amorphous structure that can distribute the nanoparticle uniformly. So whereas if you use the polymer, which is having a crystalline nature, the uniform distribution of the nanoparticles is very tough, right? So to impart radioprotective properties, the nano bismuth oxide is a non-toxic heavy metal oxide, right? So bismuth is a very high Z material generally. B2IO3 oxide. Generally, the bismuth, we cannot have the pure bismuth as an air reinforcement agent. So in the form of oxide only we can choose. So as I mentioned, it is density is also almost comparable. It is near to that of lead, right? And atomic number is 83. It's more than the Z. So hence it is chosen as the reinforcement for this polymer nanocomposite. So I'll just go on briefly how to fabricate this type of material. Maybe not interested for the particular student, but those students who are very much interested in the mini projects for MSc term and last semester projects, so they can choose preparation of nanocomposites for gamma ray shielding. Here, the preparation of nanocomposites is known to be a challenging task due to the high surface energy of the nanoparticles. Surface interaction between the nanoparticles and polymer matrix have a significant efficacy on the properties of the final product. Since the non-homogeneous distribution of nanoparticle in the matrix part and agglomeration of particle in the nanocomposites increases the surface energy, which may cause the debilation of a nanocomposite structure. So choosing the proper way to manufacture the pieces is very, very essential. So due to these facts, the polymer, polycarbonate and the bismuth oxide nanopowder mixed by solution processing. So we need to mix in the form of the solutions. Polycarbonate has a phenyl group in its structure. Thus, chosen solvent should be able to break this chain so the final product becomes more flexible. Otherwise, your final product will be more brittle. So it's not useful for our proper, while put into the application for radiation shielding, so we cannot bend as you want. So if it's a flexible, so we can bend or fold it, things like that. So for that, we need to use the solvent. It should be able to break this phenyl group. I will go to some more details of this polymer synthesis, shielding material manufacturing. So initially, I don't think these details are needed. I will go quickly, right? Initially, the 8 gram of polycarbonate was, I'm just mentioning some sample preparation, a very small level, not industry level production. So those students want to do some projects for the MSc completion, so they can choose this field as their research work. So it's very easy, since we have, I know that some of the detectors are also there in your college, JSS college, so where you can use those detector. And the only thing is you need to prepare this polymer nanocomposite for testing the radiation attenuation. Also, I hope you know, I hope you in your laboratory you also have some laboratory standard gamma reference standard sources, right? So where you can use those reference standards for attenuation studies for these newly developed polymer composites, right? So initially, 8 gram of polycarbonate are dissolved in some 40 ml of dichloromethane on a magnetic stirrer, heating at 40 degrees centigrade, and dichloromethane is quickly evaporated. And hence the piece of aluminum foil was applied to cover the top of the beaker. After 45 minutes, polycarbonate was fully dissolved in dichloromethane. Then the mixture of polycarbonate solution was loaded with a different nano Bi2O3 levels. Different weight percent of this Bi2O3 will be added. And the temperature of the mixture was kept above the boiling point of the dichloromethane. Ensure that boiling helps the nanopowder become dispersed all over the composition. Just to ensure the dispersion is uniform, so we need to keep above the boiling point of the dichloromethane. So in order to get a better result, an ultrasonic bath is also used, followed by the solution casting. At this stage, the composite was put into an ultrasonic bath for 10 minutes, and this allows the achievement of a uniform distribution. See, why I'm telling these details is that so the fabricating these polymer nanocomposites, it's not so easy. I mean, particularly the uniform distribution is very, very important. So during the preparation, if uniform distribution fails, means your material cannot be used for the shielding, because in one part of the shielding material, you will get a shielding for a particular radiation. In another part, these radiation can easily passes through. So one has to make sure that whatever this reinforcement agent, that is nanoparticles or whatever the high Z material you are incorporating to the polymer matrix, should distribute uniformly. Right. So in order to measure the attenuation coefficient of the sample in the laboratory, they should have a specific and a fixed thickness as well as the uniform surface. For achieving that uniform, so we need to use some hot press, hot press mold, so that you will get an uniform thickness of the samples. Since the dichloromethane molecules are still present, sometimes after presenting the, preparing these samples, so dichloromethane is still present in the structure. Pressing them at high temperature will simply evaporate that dichloromethane, and it causes the additional solvent to trap as wherever it traps, it get evaporated. So the polymer carbonate bismuth oxide nanocomposites were put into the oven at 80 degrees centigrade, so that all these trapped bubbles of the dichloromethane get evaporated. So we can prepare the dimension, the molds of a different dimension of our requirement. These are all some details of the manufacturers. Now I'm going to one minute. Sorry for the disturbance. So I'm going to the another the shielding material which has been developed recently by another Chinese group. In fact, this paper has been published recently in the Nature reports. I'm just mentioning that how they actually prepared and what is this uniqueness. So recently, these people, Chinese people, have demonstrated that a tungsten double layer composite yarn, right? Double layer composite yarn and polyethylene terephthalate fiber, using which they can actually weave the cloth using these fabrics, which contain the barium sulfate. And these fabrics contain the same characteristics as those of a material used in our used in the cloth production. So whatever the material we had used in our cloth production, and these tungsten double layer yarn and a polyethylene terephthalate and almost same characteristics. So that is why they can be used at low dose radiation shielding clothing manufacture, which can be used in aviation and medical and other industries. So this is the tungsten wire used in manufacture of the shielding fabric, and woven using the tungsten fabric. This first figure A shows the fabric using the tungsten composite yarn, and the figure B shows the fabric using the PET fiber containing a barium sulfate. They are having the similar characteristics of that of regular clothing. They could also develop some sort of prototype radiation shielding clothing, scarf made from PET containing barium sulfate, and apron, that radiation shielding clothing item manufactured using the tungsten carbide. See, why is very important. See, if I want to shield the particular part of the body, suppose neck part, where the thyroid and other glands are very sensitive, and if any radiation passing through that, it may lead to some cancer. The very, very sensitive tissues are there. So if I want to use the shield this particular part, we need to use the shielding material which can be cover those particular part of the body. So we should have the flexibility and other things. So then for that, people are going for this type of clothing, cloth-based radiation shielding, right? And here they actually they compared this standard shielding performance of the shielding fiber with that of the corresponding lead. The shielding performance was presented based on the lead equivalent. Lead equivalent is how do you express? So lead equivalent is equal to the mu f attenuation coefficient corresponds to that of the tungsten, and the mu v the corresponding to that of lead into the corresponding thickness. The lead equivalent FP of the shielding fiber can be expressed as the correlation between the thickness D of the shielding fiber and the linear attenuation coefficient of the tungsten and the barium sulfate and the linear attenuation coefficient of the lead. So based using this expression, they demonstrated that the cloth manufactured using the tungsten composite fabric and the PET fiber fabric containing barium sulfate, which can provide a shielding from low dose radiation with 0.018 lead equivalent. I mean, whatever the shielding provided by the 0.018 lead, the same thing will be provided by the tungsten based composite fabric, and 0.3 lead shielding, the same performance is provided by the PET fiber fabric. That's what they demonstrated. The manufacturing clothing is a lightweight. Advantages of this shielding material is that it's a lightweight and does not interfere with the work related activities. We can, as usual, use like in a scarf or like in a cloth or whatever it may be. Such a clothing is a significant important because the air, for example, in case of crew members of the air fly at higher altitudes, they're, as I told you, they're prone to expose to a higher level of natural cosmic radiations. So hence for them, it's a very suitable. And this clothing is also find use in other industries such as medical, mining industries where workers are exposed to the on-site radiation. So in those cases also we can use this nano polymer nano composites and also tungsten composite fabrics which are having the same characteristics as that of our regular clothing. I think with this I'm going to conclude my talk. So now I'm ready to take up questions if any. So Vinay,
Sir.
So
Okay, thank you, sir. So now it's open for any queries. Dear students, you can ask if you got any queries. Respected sir, so few questions has been given directly to me, so that I'm going to ask in behalf of the students. It's regarding the radiations.
Okay, please.
Is it safe for children or pregnant women to have a medical imaging procedure that uses radiation?
Okay. Any other similar questions? It's a different
and
question.
Also they ask what are the risks from radiation exposure for medical imaging, and also similar question one they have asked, how much radiation I am exposed to when I got the medical X-ray procedure?
Okay, so though it's a question needs a very elaborate answer, I will try to answer in a very little in a few sentences. Okay, see, first of all, whenever I'm going to take up that imaging part, right? When you are exposing to the radiation imaging or whatever it may be, see, generally, see, whether you want or not, we have been constantly bombarded with the cosmic radiations, right? All of you know this, right? And this equivalent dose we have been exposing constantly to this natural radiations is around some 0.02 millisievert, right? And the total radiation, total exposure in terms of a sievert, sievert is a radiation unit used to measure to account for including the biological effects, taking into account of biological effects. See, total allowed dose according to ICRP, International Council for Radiation Protection. So up to 50 millisievert for radiation workers is allowed, right? Those who are working, right? Those who are working in the radiation environment, that much of radiation is allowed. For a general public, so generally we, as I told you, used to expose to this background radiation, which is much below the what is prescribed in the ICRP. And moreover, our body, as I told you, since we are being constantly exposed to these radiations, our body is also repair some of the damage caused to these radiations. We will get this effect will get more when the rate of exposure or rate of damage is more than what the body can recover, right? Body can recover. Means if for exposure to the very high intense radiations, it will be a problem. Otherwise, this imaging, of course, if you're constantly going for medical imaging and things like that, definitely there will be a certain effect are there, but that is not a problem as far as the recovery of ability of the body of any individual is concerned, right? But unnecessary exposure and for a long time is a very dangerous. For example, if you are unknowingly, if you are daily working in the radiation environment or some radiation source kept in your room, if you don't know the where exactly that radiation, if you are regularly sitting on those radiation area, definitely that will be the danger. Even for a low energy radiation, if you are exposing very constantly for a longer period, then it will be a problem. Otherwise, yeah, please.
Okay, sir. Sir, and also one more question from Gagan CS. Directly they've asked, sir, does every object emit radiation in very small quantity, including human body?
No, actually, every object is, I don't know in what construct is whether he's talking about thermal radiations or I don't know. If we are talking about the nuclear radiation, no, all object will not emit. But of course, in all our bodies, so as you know, the K40, right? I mean, potassium K40 nuclide will be there. That anyway, it's inescapable, but that won't affect. That won't affect. That K40 is there. It's a radionuclide, but the quantity is very, very, very less.
Okay, sir. Due to running off of time, so we
I hope I have answered.
Yeah, sure, sir. Yes, please, sir. Please tell me.
No, if I answered, it's okay. Otherwise, you can have some counter questions so that I can make it more clear.
Okay, the students have been satisfied, sir. So, and also we are waiting for next session. So I'm going to conclude. Thank you, sir, for your valuable and thought-provoking knowledge towards radiation. And also on behalf of the college and myself, and also from organizing committee, thank you for your valuable time and sharing your thought-provoking knowledge once again, sir. Thank you, and thank you, sir.
Okay, thank you very much. And let me express my sincere thanks for providing this opportunity. Particularly the Manjunath Guru sir and Vinay and other all faculties of the Department of Physics. Thank you very much.
Oh, thank you, sir.
Thank you.
Okay, now I request Mr. Sunil Kumar to take over the next session. Please, sir.
Hello.
I'm here.
Hello, Nagaraj sir, ಕೇಳ್ತಾ ಇದೆಯಾ?
Yes, sir.
Hello.
Yes, sir. Audible.
ನಾಗರಾಜ್ ಸರ್ ಕೇಳ್ತಾ ಇದೆಯಲ್ಲ? Hello.
Yes, sir.
ಏನು ಬೋರ್ಡ್ ಮುಂದೆ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಇದೀರಾ ಅಂತ ಅಂತಿದ್ದೀನಿ.
Yeah, it is classroom is already.
ಹೌದಾ? Thank you very much. Now, Ms. Sunil Kumar, the faculty of the department, will give introduction. Right, please.
Let us make very brief.
Thank you, sir. I will very briefly, I will introduce the second resource person for this webinar. The second speaker of today's webinar is Dr. Kamsali Nagaraj sir, working as an associate professor in Department of Physics, Bangalore University. Sir obtained his master's from Coimbatore University and he also done his PhD in atmospheric science from University of Mysore. His research field of interest includes atmospheric science, meteorology, monsoon studies, cloud physics, dynamics of the atmosphere, aerosols, atmospheric electricity, global electric circuit, solar variability, climate change, and modeling studies. Sir has many collaborations with many institutions such as Indian Meteorological Department, Indian Space Research Organization, Bangalore, Indian Institute of Astrophysics, Bangalore, Indian Institute of Tropical Meteorology, Pune, National Atmospheric Research Laboratory, Bidan Chandra Krishi Vishwavidyalaya, Manipur, West Bengal, George Monsoon University and Kola, USA, University of Washington, United States. Currently, Dr. Kamsali Nagaraj sir is having 8 research projects from UGC, DAE, BRNS, ISRO, Respond, USA, and atmospheric science, meteorology, weather studies, surface observation, upper air observations, aerosols, satellite meteorology, remote sensing, TZ, gravity, gravitational waves, atmospheric electricity, GEC, studies of maritime atmosphere, and modeling studies worth of almost 4.6 crores. Dr. Kamsali Nagaraj is serving in more, having almost other responsibilities such as he is Secretary for Indian Meteorological Society, Bangalore chapter since 2013. He is the coordinator for Sir M. Vishweshwaraya ISRO chair since 2012. He is the coordinator for atmospheric and space science course for Masters in Physics, supported by ISRO since 2010. COSPER, associated COSPER International Space Agency since 2008. Kamsali Nagaraj sir has 82 research publications in international journals and 32 publications in scientific reports and proceedings and books, 134 presentation in national and international seminar, conferences and symposia. On behalf of the college and the department, I wholeheartedly welcome Dr. Kamsali Nagaraj sir for this webinar, for making his time to address our students. Thank you, sir, for coming, and over to you, sir.
Thank you. I'm audible here. Yeah, thanks for the nice introduction. Behalf of that, I would like to tell you in such a way that I am very good friend of our Dr. Manjunath sir, actually. Manjunath Guru sir. Pranams to Swamiji, and thanks to the principal, the head of the department, physics faculty, and also the participants who are listening to me. I hope I am audible to you. Kindly permit me as a co-host, that's far better, to share the screen and also to control the audience. Who is in technical team right now?
Yes. You can share, Nagaraj sir.
Okay. Yeah, this is the topic what our Manjunath Guru sir has given me. Role of a physicist in placing the satellite into an orbit. Okay, I thought that putting the satellite into an orbit, he renamed it as placing the satellite into an orbit. Thing is that our role is not only to put the satellite into the orbit. For several applications, we need, me particularly as a physicist, what is our role actually? Okay, don't think that it is only for the role of a scientist or a role of only people who are working in R&D or a role of a people who are working in the field of the space science to take care of the putting the satellite for some of the applications. I am working in Bangalore University as a faculty. Before that, I did my PhD in Mysore University along with our Manjunath Guru sir. Actually, we were together. He guided me a lot. We are having a very ample amount of time for discussions. Actually, without the discussions, you can't achieve anything, either in classroom or in your laboratory, or even wherever you are there. Actually, at least the discussions makes you a fruitful results of achieving the thoughts or understanding the thoughts, understanding the concepts. The very purpose of doing such type of seminars, particularly for the student fraternity and also for the faculty members, is to enlighten, provided the speakers are well versed, or even if you show the interest to listen to the speaker in a good way, that makes the sense and makes the institutions to be happy with the conducting of this type of an events. Actually, a lot of efforts will go for conducting this type of an event. You may not aware of it. Actually, attending or participating for 1 hour is not the mere end of the taking the informations. Okay, thanks. I'm congratulating you, the institutions, for holding such type of an event. Actually, I don't want to touch much upon it. In the background, you can see that our head office, that is the head of the institution, actually, Gnana Bharati campus. Most of the time, it is known for unusual things, but at the same time, the Bangalore University is well with the research in research frontiers actually. I'm working in the physics department. I will take you to the next slide in such a way. Hope you might have seen that. Very good. Your students may be sitting in the classroom or maybe attending through online mode. We are not sure of that, maybe while conducting the step. This is the institutions where you are placing, I don't know, maybe this is entire thing is JSS College of the Arts, Commerce, and the Science too together. On the top, you can see that I want to take you to the role in such a way that people are ventured, means the scientists are venturing. Earlier, even bureaucrats are also venturing. The economists are also venturing to move from one place to the another place to seek the information as a scientist, to seek the resources as a business magnets, to seek the valuable things as a navigation. Means maybe a journey to the Mars, maybe a journey to the moon, maybe a journey to the other planet, or maybe a journey to from one place to another place. You reach your JS institution right now in an offline mode by different mode. Earlier, people used to go, this is the one case. Instead, is the drilling balloons they can call, maybe the aeroplanes, maybe the cards with the, what we can call a certain kind of a dog team actually. Okay. This is with the, some with the scooter of that kind. There's a fourth one. And a fifth is with the Russian trolley. And this is with an siege they can call, maybe with the camel, particularly on deserted area, or maybe a kind of an engine, railway engine actually. And this is an updated version, updated in the sense the later version of that one, or maybe an out of that kind. It's a beautiful place for you. JSS institution looks like this. How to reach this institution JSS? Is it a task? Maybe by two-wheeler, maybe three-wheeler, maybe four-wheeler, or maybe a jeep, or maybe auto, depending on the weight of your horse and also the mode of accommodations. But if you want to go somewhere else apart from here, another picture I will show you here. This is an international airport in Bangalore. Maybe if you are nearby, you can take any of those things. At the same time, I would like to show that there is a great number here actually. What are these numbers indicates? As a being a physicist student, to plot a graph from the origin, maybe x-axis is termed as the latitude and y-axis is the termed as the latitude and x is termed as the longitude. If you take the globe and a globe Earth actually means 12 degree 28 minutes, not it is a fraction of course, and 76 degree east is the thing which is going on. I will take this number. I will show that how you can reach this place in a short amount of time. Maybe are you able to see the screen? Yeah. Okay, sure. I will put this number. See that? Going. If you are watching on your mobile, maybe a difficult task. Still it takes. Where you are sitting? Near the yellow marker? Maybe, more or less. See the digits, 12.28 followed by so many digits. It goes to the an accuracy of a meter, means within a meter you can find that what it should be there actually. Okay, means these type of the things can be achieved by the satellite technology. Means there is the technology of putting the satellites into a particular orbit or desired orbit for the applications. What kind of an applications we will see later actually. And of course, this is the Google Earth you might have noticed. You can travel from one point to the another point while moving either by maybe public transport or maybe your own vehicle. You will use the GPS. GPS will find you exact point to the extent you wanted to reach the destinations. I'll come back to the presentation here. Again. Yeah, if you are interested to land to see the Agra, certainly a mode, whatever I shown on two-wheeler may be a difficult task, maybe by car fine, but from Bangalore or maybe Mysore still is true, you can fly. Maybe you can make use of any of the aircraft airlines actually. If you want to go to any of the island, certainly the motorcyclist, two-wheeler, four-wheeler may not be sufficient. You can go with the cruise or have to take the aircraft. If you want to go for moon, if you want to see the moon, if you want to understand the moon, or if you want to make a colony on moon, certainly the rocket science is required, rocket technology is required. And even if you want to land on Mars, people are trying actually. Why one has to go to the moon or Mars? Actually, one is to extract resource, means that is the resources. Maybe any valuable elements are there. Maybe gold is a valuable element, platinum is valuable element in terms of economy. But apart from that, maybe the medicinal applications it can expect, or maybe some other element. In periodic table, you might have found that about 118 elements so far. Every day, people are trying to search for the new elements. Certainly, the periodic table will also enlarge, not in terms of the size, but in terms of the number of the elements while going with the exceptions. Maybe people are trying to go for the exoplanets, I can call what Manjunath Guru sir has told in the beginning. Okay, maybe exoplanets, maybe planets may not belong to the solar system. Some of the planets which are surrounding the Earth actually, maybe they are the neighboring celestial objects for the venture. Even the moon, the nearest celestial object, is about 384,000 kilometers away from us. Mars is almost 75 million kilometers away from the Earth actually. And is it the right environment for the living organisms to stay there? That one has to see that. You will see that in my slides. This is one of the beautiful picture. It is not the animation actually. Sun is not stationary. This is the movement of the sun. The bright spots what you are observing are the black spots they can call. Black spots or dark spots they can call. They are the region with the lesser in temperature compared to its surrounding. Okay, about some 4,000 degree Kelvin. The surface temperature of the sun is about 6,000 degree Kelvin, where these spots are called the sunspots. If you take a photography, it looks like a dark or maybe blackened region they can call, relatively cooler compared to its surrounding, about some 2,000 degree Kelvin. On the right side, you can see the list, a big list, which is showing actually is the different missions which have ventured to go to go to the sun actually. Pioneer, Helios, Ulysses, Wind, Soho, and Parker. You might have heard very recently, about 2 years back actually. Parker is the name of a scientist. Still, he is alive, and they have put the name for the mission on his name. All others are different. Aditya L1, where ISRO is planning to study the moon by sending the satellites. It is not easy job. Sun is at a distance of about 150 million kilometers away from the Earth actually. Even if you travel 100 kilometers per hour, think of how long it will take. Or even 1,000 kilometers per hour, think of how long it will take to reach the sun. Maybe may not for landing at least, to study the features from far away. Yeah, great science has come. In fact, rocket technology has started by Tipu Sultan, who ruled the Mysore provision actually. Mysorean rockets were an Indian military for the first iron cast rockets. What they have made actually, see that's this thing. This is, he used the world's first war rocket against the British people, a long bamboo stick actually, with the some 2 kilogram gunpowder put at the sword as its weapon. Each rocket weighed about some 3.5 kilogram and traveled 1.5 kilometer. Imagine, just throw a stone, maybe up or horizontal actually. Up you can go to the extent of 2 meters. Maybe if you are so strengthened, then maybe about 50 meters to 100 meters maximum. Horizontal, maybe 50 meters. You might have seen that the people who are participating in volleyball or throw ball or such type of things, or javelin ball. Sorry, might have taken to the maximum extent. 1.5 kilometer taking a weight of about 3.5 kilogram is not an easy task. The history says that the Tipu Sultan was the first person who built the rocket technology under his tenure. Thanks to Professor B.N. Suresh, he shared this slide for me actually. He's a well-known scientist in Indian Space Research Organization. This gallery is put at the Artillery Museum in the Woolwich of London. Okay? The Mysorean army under the Hyder Ali and also his son Tipu Sultan. This is not a spell mistake. For the Tipu, they will use the both words TIPPU or TIPU. Used the rockets effectively against the British East India and Company during the 1780s to 1790s. Some of the marvelous tools what he used was also kept in museum in Srirangpatna. If you are having a time, just have a visit. Sorry. The great journey of these things has started with the very place called the equator. We are having two kind of an equator. One is geomagnetic equator and a geographical equator. Okay. See that these two lines on the right side top diagram, actually, the central line is the magnetic equator, means the 0 degree of the magnetic equator passes exactly at the foothills, not foothills, the tip of the India, peninsular India, maybe Sri Lanka and the Trivandrum, where Ananta Padmanabha temple is there, or Kerala, that is the place actually. But from magnetic geographic equator, we are about 5 degree towards north. 5 degree towards north. I told one value in the beginning to reach your JSS institution, that is about some 13 degree north from actual equator. It is about 13 degree. Each degree is about 110 kilometer. You multiply it by 110 with 13, roughly about 2,400 kilometer you are away from the equator point. Okay, these are the lines actually. How means you, as a physics student, you know that actually being a magnetic field, the earth is having a huge magnet, north at the top and the south at the bottom. Magnetic fields of lines of forces are moving from northern to the southern region actually. Any charged particle which are coming either from sun or maybe any other planets or maybe other kind of stars will not reach the equator, because charged particles will never enter horizontally. B cross E, E cross B, you can take A cross B, it should be the maximum. Okay, then those charged particles has to enter from the polar regions, where that leads to the beautiful, fantastic phenomena they can call auroras. Aurora australis over north, aurora borealis over the south. And in fact, the journey to this space means after crossing the atmosphere, they can call actually, has started in Tumba. Tumba is very closer to the magnetic equator, which has some unique geophysical phenomena. One of them is the equatorial electrojet, they can call, or even the current which are moving at the height around the 110 kilometer directly over the magnetic equator. Dr. Sarabhai, one of the pioneers in the space physics, argued that a sounding rocket, sounding means the radio sounded waves they can use for the signal to be tracked actually, range could be established to study the unique phenomena, particularly in this region. At that time, the bullock carts were used actually to move from one place to the another place, and also to carry the any of the also to for the transport, they can call. Doing this, yeah, my God, this is a church actually at Trivandrum, Tumba they can call, need not be Tumba exactly. Saint Mary's Magdalene Church, which was used for fishing village of the Tumba. It is right now served as the, what happened actually when Space Science Office earlier, now ISRO, earlier Space Science Office thought of having its office actually for this space activities, particularly to have a capability and a capacity to send these satellites into a desired orbit for some of the applications that we'll see later. From the day having a church, this church has a control room they have made, okay, and a bishop house very next to it actually they used that one as the office, and bicycles were used for ferry to carry the heavier obstacles from one point to the another point, and the naked eyes without the aid of any telescope or any of those tools, they use this to have the tool for tracking the smoke plume. In fact, particularly what happened when Vikram Sarabhai and others went to the Kerala, particularly Trivandrum, to choose that place as the space station actually, they tried to convince the father of the church, can we have this land for this space science program or space program, they can call actually. It was a village, they can call Kolli, Kolli means that is the corner, very next to the Bay of Bengal, very next to the Arabian Sea, very next to the Arabian Sea. The father of the church called all the village people, most of them Krishnaris actually, and he convinced. This is the place where it can take the space science activities and will become part of the country's achievement in putting the space science activities to the nations. Okay, and they convinced and they gave the land of their own for the space science activities. And the church, they took it for the laboratory. That is the first laboratory in India to start the space science activities. Means to say, your JSS institution is spending lakhs of rupees, maybe crores, sorry, for for you to try, for you to judge, for you to make some experiments, for you to have an hands-on, either in physics lab or electronics lab, or maybe computer science, or maybe chemistry. You will acquire knowledge with with the expertise and faculty members in your institution. Means that's one kind. And the money alone is not the criteria to learn science. The money alone is not the criteria to venture. The money alone is not the criteria to do the PhD program or research program. Means ideas, thoughts, knowledge, and thinking, particularly critical thinking in subject, make you a scientist. Who is a scientist? If you ask a question to a kid, whoever is having an attitude to think, who is having an attitude to solve the problems what they're having, need not be numerical problems of 2 plus 3 is equal to 5, or maybe 5 minus 2 is equal to some value, or something value divided by x by y is equal to z is not the thing, or maybe solving some Schrodinger equation, solving some trigonometric functions, need not be the criteria of that kind. If you think of that kind, why it is happening, how it is happening, what is the cause for that, what is the reason behind it, then certainly the people will call them as a scientist. Means there should be a gesture for that. Humble beginning has started with just, of course, it is it's a ritually also a good thing. And converting a toilet into a satellite data receiving center for India's first satellite, Aryabhatta in Bangalore. In Bangalore also they faced the same problem, particularly the Professor U.R. Rao is no more. We are sorry for this demise. They converted one of the toilet room into this satellite data receiving center right now. Okay, Indian Space Odyssey or journey have come a long way, starting from ferrying foreign satellites. I don't know, you might have heard actually, a few years back, India was capable of putting 104 satellites into the space. 104 satellites. Even they put an effort of launching the satellites of other countries to the desired orbits, along with our own satellites. Several satellites they can call will come back into the orbit, and even to reach the moon, launching the satellites to the moon, landing on moon was being missed in Chandrayaan-2. Only landing is missed, but still the satellite is revolving around it, and even landing on, orbiting on Mars at the first attempt, and now planned to land on Mars in Chandrayaan-3. That we'll see later. How it was started. See that these are the beautiful pictures. Just for curiosity, I am putting actually. Okay, space science, astrophysics, astronomy is good for you in terms of the diagrams, schematical representations, and also pictorial representations. At the same time, it's too complicated to learn, to understand the phenomena. Left top corner, you can see that our own ex-president APJ Abdul Kalam sir, who is on left, working with the ISRO, taking the satellite top, Safari. Okay, see that bigger one, NK Apache sounding rocket being made ready for launch actually from Tumba only. Vikram Sarabhai on left side, and again, and through a telescope they are trying to observe Abdul Kalam, Professor Sarabhai. The one with Kalam, you can see that here actually, and earlier also this is a Sarabhai at Sriharikota, we can call Shar Center right now, and this is the one after they declared that Tumba. Now, that from that day onwards, the earlier Prime Minister Indira Gandhi ji madam, it is dedicated to the UN. TERLS means Tumba Equatorial Rocket Launch Station. Tumba Equatorial Rocket Launch Stations. It is dedicated to the UN nations, being one of the established and frontier areas of institutions who are working on space science. This is the Apple they can call. Apple means Arena Passenger Payload Experiment. They used to do it on a bullock cart. Bullock cart taking the spacecraft one point to the other point as a transport one. Another thing is that to test the electromagnetic cleanliness, if there are vibrations when they are moving on a bullock cart, the satellite has to sustain those vibrations. After attaining those vibrations, satellite has to perform. It is not an easy job. You will give service for your vehicle after maybe 6 months, maybe 1 year, on maybe 2-wheeler or maybe 4-wheeler. If you send a satellite to the any desired orbit, satellites will work for years together. Some of the satellites will work for 10 years. One of that, the NASA's mission is working from last 25, 30 years actually. It is not an easy way. Means no machinery has to go wrong. No machinery has to malfunction actually. Okay. Yeah. What I told the Tumba Equatorial Rocket Launch Station during 1963, that was the humble beginning of the space. Now they have converted that laboratory into a museum. You can you can visit and see that they have placed all satellites and other things as a model. Actually, it is allowed on every Wednesday. And next to that, they will launch the India's first rocket sounding rockets, they can call. It works on the radio Sunday with the Nike Apache. That was during 21st, 1963. Okay. Turning the heads upwards. Of course, physically also. Physical in the sense, you want to see the movement of the rockets upwards, you have to uplift your head. At the same time, turning the heads upwards, particularly the entire world was looking towards India. India is capable of having the space station. India is capable of having the space studies. India is capable of having launching and working with their own satellites. ಕನ್ನಡದಲ್ಲಿ ಅದನ್ನೇ ಹೇಳ್ತಾರೆ, ರಾಕೆಟ್ ಉಡಾವಣೆ ಯಾವಾಗಲೂ ಸಾಮಾನ್ಯ ಜನರನ್ನ ಮತ್ತು ವಿಜ್ಞಾನಿಗಳನ್ನ ಸಮಾನವಾಗಿ ಪ್ರಚೋದಿಸುತ್ತದೆ. ಅದು ಸೌಂಡಿಂಗ್ ರಾಕೆಟ್ ಆಗಿರ್ಬೋದು, ಈಗ ಏನ್ ತೋರಿಸ್ತಾ ಇದೀವಲ್ಲ ಅದು, ಅಥವಾ GSLV MK Mark III, which carried 400 tons of payload. A lorry is about hardly 10 ton. Hardly is about 10 to 12 ton. 400 tons, equivalent to almost 40 lorries weight. It took from Earth to the distance of about 4 lakh kilometers to keep the satellite onto the orbits of the moon. Vikram Sarabhai and others. See, that is fantastic. It is an achievement, actually. See that? UR Rao Satellite Center. After UR Rao, the ISRO has made the center as earlier it was called the ISRO Satellite Center, ISAC they can call. They renamed it as the UR Rao. That is a contribution from a person who is from Karnataka, Udupi Ramachandra Rao, actually named Udupi Ramachandra, who contributed a lot. Who was the first person who became after Vikram Sarabhai, the chairman for the ISRO for 2 terms, almost 10 years actually. At the beginning, see that how that Bangalore was there. This is the first satellite, Aryabhatta, and it was there during 1975. ಅವರೇ ಹೇಳಿದ್ದ ಅವರದೇ ಮಾತಿನಲ್ಲಿ, ಬೇರೆ ಒಬ್ಬರು ಅಥವಾ ಬೇರೊಂದು ದೇಶ ಮಾಡೋದಕ್ಕೆ ಸಾಧ್ಯವಾದರೆ ನಾವು ಕೂಡ ಅದನ್ನು ಉತ್ತಮವಾಗಿ ಮಾಡಬಹುದು ಅನ್ನೋ ಒಂದೇ ಒಂದು ಕಾಳಜಿಯಿಂದ, ಒಂದೇ ಒಂದು ಆಸಕ್ತಿಯಿಂದ they built. Entire Aryabhatta was built in 2 years. Of course, your graduation period is for 3 years. Still, you can do it actually. There is no extra knowledge. There is no extra talent. There are no extra anything else which is required to do science. Okay, just I will go with fast actually. Here, what happens? India's space strategy goes in such a way. Particularly the Western countries like America, Europe, Russia, they first worked with missiles to attack against enemies. For the missiles to be taken from one point to the another point, okay, they invented. Of course, they worked on launch vehicles. Those after invention of the launch vehicles, they worked with the satellites to keep them in the orbit. After designing the satellites, after what we can call achieving the working of the satellites actually, then they thought of what kind of an applications they can put. That is for the superpower space strategy they can call. But in India, our goal is in the reverse order. First, we want to know that why we want satellites. See, for example, if I want to study the Earth's features, where the land is there, where the ocean is there, where agricultural land is there, where water body is there, where ocean is there. Or if I want to have some tool, some mission for the communication, I want to talk to you over phone. Okay, from Mysore to the Bangalore. Right now I'm from Bangalore actually. Okay, how can I use the technology? For that purpose, they thought of the application purpose. To achieve that applications, they invented the satellites. Invented means they worked on the satellites to achieve those applications. Once they got the technology and capability of designing the satellites, then they thought of the launch vehicles to put the satellites into the desired orbits. ಮೊದಲನೇದು ಏನ್ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ, ಕ್ಷಿಪಣಿ ಎನ್ನುವುದು ಬುದ್ಧಿವಂತ ಮಾನವರಹಿತ ರಾಕೆಟ್. ಅದನ್ನ ಗುರಿಯನ್ನು ನಾಶ ಮಾಡುವ ಉದ್ದೇಶದಿಂದ ಪೇಲೋಡ್ ಅನ್ನು ಗೊತ್ತುಪಡಿಸಿದ ಹಂತಕ್ಕೆ ಕೊಂಡೊಯ್ಯಲು ವಿನ್ಯಾಸಗೊಳಿಸಿದಂತಹ ಒಂದು ಸಾಧನ. ಆದರೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫಾರ್ ಇಂಡಿಯಾ, ನಾಟ್ ಫಾರ್ ಕರ್ನಾಟಕ, ವ್ಯಾಪಾರ ಅನ್ನತಕ್ಕಂಥದ್ದು ವ್ಯಾಪಾರ ಸಂವಹನ ಫಾರ್ ಬಿಸ್ನೆಸ್ ಸ್ಟ್ರಾಟಜೀಸ್, ಅಭಿವೃದ್ಧಿ ಸಂವಹನ ಮೀನ್ಸ್ ಡೆವಲಪ್ಮೆಂಟಲ್ ಆಕ್ಟಿವಿಟೀಸ್, ಮೊಬೈಲ್ ಸಂವಹನ ಫಾರ್ ಕಮ್ಯುನಿಕೇಶನ್ಸ್, ಇಂತಹ ವಿವಿಧ ಉದ್ದೇಶಗಳಿಗಾಗಿ ಸಂವರ್ಕ್ಕಾಗಿ ನಾವು ಸ್ಯಾಟಲೈಟ್ಗಳನ್ನ ಮಾಡ್ತೇವೆ. ಆ ಸ್ಯಾಟಲೈಟ್ಗಳನ್ನ ಒಂದು ನಿಗದಿತ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ಇಟ್ಬಿಟ್ಟು ನಮ್ಮ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಗಳ ಸಾಧನೆ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕಾಗಿ ನಮ್ಮ ಎರಡು ಬೇರೆ. ಇದಕ್ಕಾಗಿನೇ ದೇರ್ ಆರ್ ಸಮ್ who question the relevance of the space activities in a developing nation. To us, there is no ambiguity of the purpose. Okay, we are convinced that if we are to play a meaningful role in the community nations, we should be second to none in the applications of advanced technologies to the real problems of man and society. This is the quote made by the Vikram Sarabhai. Of course, you are also told the same thing. If some other countries are doing, if some other persons are doing, why can't we? We should, we also have the same capability. We also have the capabilities to have such type of knowledge. ಬಾಹ್ಯಾಕಾಶ ವಿಜ್ಞಾನ ಸಂಶೋಧನೆ ಮತ್ತೆ ಗ್ರಹಗಳ ಅನ್ವೇಷಣೆಯಂತಹ ಅನುಸರಿಸುವಾಗ ರಾಷ್ಟ್ರೀಯ ಅಭಿವೃದ್ಧಿಗೆ ಬಾಹ್ಯಾಕಾಶ ತಂತ್ರಜ್ಞಾನವನ್ನ ಬಳಸಬೇಕಾಗುತ್ತೆ. ಅದನ್ನು ಬಳಸೋದಂತಹ ಮೊಟ್ಟನ್ನು ಇಟ್ಟುಕೊಂಡಿರೋ ಸಂಸ್ಥೆಯೇ ಇಸ್ರೋ ಅಥವಾ ಭಾರತೀಯ ವಿಜ್ಞಾನ ಸಂಸ್ಥೆ ಅಂತ ಕರೀತಾರೆ. There was a quantum jump, okay, journey to start from space. See, in 1972, when they launched the Aryabhata, the emblem of that Aryabhata, logo of that Aryabhata was put into a 2 rupee currency at that time. Of course, you may not see the 2 rupee; it doesn't have such a high value. Not high; it's such a value. Okay, then the remote sensing technology has grown to a larger extent to study the entire country, particularly for Indian based actually. Recently in 2000, they put an effort to put the satellite into the Mars orbiter missions, MOM they can call. They put that the logo into the 2000 currency. 70s, Aryabhata, first satellite, maybe 2 rupees currency, equivalent to that. They might have spent few lakhs. While sending the satellite to the Mars, they spent hardly about 450 crores. 450 is nothing. So many Hollywood and Bollywood movies also, they are spending so much of crores, more than 500 crores to make a movie for the enjoyment and entertainment. Okay, that ISRO rocks it. This is one of the Amul product. They were saying that make the planet to take off the satellites from one particular planet. On the top, you can see the life cycle of the sun. Actual physics will come into the picture. A star can be there for about 10 billion years. The sun has completed 4.56 billion years. Still, it can live for another 5.5 billion years. Afterwards, it becomes red giant, then nebulae. Due to the highest gravity, it gets collapsed into the white dwarfs. And the bottom panel, you can see that left extreme is the sun. Okay, then maybe the different planets according to the size. Now, Pluto is excluded as a planet because it is one of the dwarf planet. Earth is the third planet from the sun. We are at a distance of about 150 million kilometers. Maybe in the WhatsApp, you might have seen this type of a beautiful structure for the planetary system. All planets will never align in the same structure. It is not like a necklace what your girls are wearing actually. It will never align of this kind actually. It is of different thing. Okay, means it is only for pictorial representation. Okay, the actual position will be like that. Okay, otherwise, due to the center of mass, sun at one of the center, planets are revolving around it. It is a fixed orbit. It will never align according to that. You can see this. With one of the clippings, you can see that. ISRO also had made a beautiful journey and succeeded in putting the satellite into the Chandrayaan, that is the moon, where it carried about 104,400 kilogram or 1380 kilogram with different weight. It was launched on 22nd October 2008 actually, where your school days might have started at that time, where it carried a Polar Satellite Launch Vehicle 11, that is a number, series number actually, with 313 tons of mass when it was launched. Normally, when the satellites are going for an outer orbits or maybe even for the desired orbits, it will never go straight. Like a cow can fly from one point to the other point. Two regions. One is that it will launch from at this point actually. Okay, it will take an elliptical orbit, then it will be fired once again. It will go to the next orbit, then maybe a third orbit, fourth orbit, then it will go on land of that kind. This and high technology is there actually. This is the earthbound bound orbits they can call. And while landing also, it will never straight away enter. First, it will go with the extreme orbits. Okay, then it will come interior, then slowly coming interior, then it will take some desired orbits or maybe placed into the orbit, into the celestial body, either for moon or maybe for Mars. This Chandrayaan 1 has having some 11 scientific sensors. One is to study the solar wind, how that the solar wind is affecting the moon. Another one is the energetic particles, energetic analyzer. See the dimension. It is not more than about some 5 meter by 5 meter of that kind, 5 by 5 meter. Less than the dimension of your classroom, of where you are sitting with some 30 to 40 capacity. Okay, and high energy X-rays and another payload. then hyperspectral images to see the images, mini synthetic aperture radar also they have put. Okay, moon mineral mapper actually moon mineralogy mapper to understand that the beauty, maybe the iron or gold or nickel or copper, depending on the spectrum what they receive. Those spectrum will be received on the Earth. Then compact imaging X-ray spectrometer. This is the terrain mapping, only to see that either whether mountains or hilly area or valley of that kind. Then lunar laser ranging instruments that can be ranged actually. Then infrared spectrometry to see that what kind of radiation the moon emits, and radiation dosimeter, whether the radiation in the environment of the moon is sustainable for the life. Dr. Ishwarappa has enlightened all of you in the earlier to my talk actually about the feasibility of the radiation. We'll go there. This beautiful figure. See that this is the crater. It is not on Earth. This is on the moon actually. This is the Rayleighs. Okay. Here you can see that the movement of the water or any kind of liquid, need not be water, okay, will be of that kind. These type of features. This is a resolution of about 5 kilometer by 4.5 kilometer entire picture. Okay. It was the pass was taken. Photography was taken on 23rd of November 2008 actually. Okay, here on the left bottom corner you can see the entire map of the moon with bluish color on the polar region. It showed that us or envisaged us that confirms that possibility of existence of water on moon. Mars is the next planet. People went there actually, say, including other countries, particularly NASA was the first. NASA made several attempts to reach the moon or Mars, but India also made. Fortunately, fortunate in the sense I'm saying that with higher technology and the actual calculations, it reached at the first time. It's at a distance of about 1.52 times from the Earth, times as far as the Earth. Earth is about 150 million kilometers from Sun. Mars is about 225 million kilometers away from Sun, about 75 million kilometers from the Earth. Time to orbit the around is about 26 Earth months. Mostly it is made up of carbon dioxide. And the time of the day is that it also takes about hardly 1 day to rotate on its own axis. Temperature of the planet which hardly rises above the freezing point. It's always it is sub-zeros, but minus 200 is the temperature over the Mars. Why one has to study Mars? Property of Mars lies almost similar to that of the Earth. Mars is almost like a little brother for the Earth. Okay, see that this is the polar region is with ice cap, and tilt is also about 23.5 degree. Okay, day and night you can expect. Rotation is also the similar, but you can see that. Because here the Earth is almost like the thing. The white patches you are seeing the clouds. Bluish color is with the oceanic environment. Gray color is with the landmass. While launching, I will not go much here. This is a scientific technology which is required. PSLV, Polar Satellite Launch Vehicle, is the one where it is made up of the several stages they can call. First stage, second stage, third stage. In your final year graduation, you might have studied the rocket technology, particularly the overview. This is the first stage in white color, second stage, third stage, then rest of that is the fourth stage. Very purpose I put here is that the first stage is about 20 meter in length. Here, is it not? Okay, about diameter of about 3 meter, 2.8. The fuel propellant is about solid propellant. The science comes into picture, physics comes into picture in such a way. 138 tons of fuel they will keep here. 138 tons, particular for PSLV. It varies from payload to payload, where it can give an energy equivalent to that of 4,800 kilonewton. That entire 138 tons of fuel will be burnt in 1 or 3 seconds, less than 2 minutes. Imagine, work out with E is equal to mc square. Mass is about 138. The speed may not be of that of the sea actually, but here thing is that within 1 or 3 seconds you will get an energy equivalent to about 4,800 tons, where it can uplift the weight of about 400 tons of mass upward against the gravity. If you are increasing the speed, it may collapse due to the friction. If you are decreasing, it may fall back onto the earth actually. Again, the mission will go off. If you are increasing the temperature, increasing the energy, it may burn also. The electronic circuitry has to sustain. The mechanical devices has to sustain this energy, this force actually. Okay. Second stage, about 50 seconds, it will burn with 12 tons. Third stage and final stage will burn with a height of about 600 to 1,000 kilometers. Then satellite will fly. That I will show. These are the Mars missions. Only about 5 sensors they are kept actually. 5 sensors. How that Mars mission has started? It will go in an elliptical orbit, and it has traveled 300 days before reaching the Mars. before reaching the Mars, it has traveled 300 days. When, see that here now, the physics comes into the picture again actually. See, this is the one is the start, departure of the satellite at the beginning. The position of the Mars was here, somewhere here. Mars at the departure. Okay, it started, it encircled several times. This is the position of the Earth and enter into the orbit. This is the blue color is the Earth's orbit. When Earth at insertion was this position, the space trajectory has traveled like this. Okay, when it was launched, Mars was somewhere here left actually. When Mars traveled 300 days, 10 months, Mars came to this position, where Earth came to this position, then immediately enter into it. Now, I can assure that Manjunath Guru sir, or even his own students, might have missed the buses several times without taking into account of the exact time of the travel. You might have missed the trains several times if you are unable to reach the railway station in time. Okay, particularly if you are living in Bangalore, people will never expect the traffic actually. Certainly, even they might have missed the trains, even aircraft, where they have been locked. But thing is that at the time this was the launch position, Mars was here. They have to calculate the sorry, distance of separation, the angular speed, the rotation of the Earth, rotation of the planet Mars, even though it is about 75 million kilometers away from us, this satellite, and everything should be under your control. Once the satellite leaves the Earth, nobody will be there to control the satellite, okay, except changing the orbit. Actually, you can't increase the speed abruptly. You don't know how the environment will be there, how the space will be there, what kind of the objects you will come encounter. Some orbit you may encounter with some of the meteorites, some of the comets, some of the other kind of satellites, even some unknown satellite, some unknown celestial bodies also will encounter between the Earth and the Moon actually. And when you are taking here, exactly Moon has to, exactly the satellite has to reach when the Mars has to come. Okay, this is a real challenge that we'll see. Some of the pictures I will show you. Okay, this is with the technology. This is one of the laboratory in Bangalore actually. They can call spacecraft being prepared for vibration test. If you vibrate continuously, okay, your devices has to work. It is not the easy job. Maybe you can keep your mobile in vibrate mode for months together. Can you expect it will work? It's a tough task. They will make the testing of the vibrations. Okay, means vibration means you are giving service for your two-wheeler, because whenever you are moving from one point to another point, due to the vibrations, some of the mechanical devices may get loosened or maybe get tightened. That should be rectified actually. This is another lab to test the acoustic test. Well, if something is moving in space with this sound, okay, space in this sense, acoustic waves will be there actually. Those acoustic waves will perturb. If you, I don't know, maybe you might have heard some of the experiments actually. Even if you are unable to break the glass plane of a cube, a glass plane of a cube actually, cube or maybe rectangle, with any kind of a force, maybe either you jump from top to bottom or you hit by a hammer, the glass plates may not break. But thing is that if you use the simple tuning fork, okay, simple tuning fork, use a tuning fork where the frequency of the air within the cube, if it matches with the frequency of the tuning fork, certainly your glass plates will break. Okay, here also the same case actually, acoustic test, they will do that. That is a sound vibration test. Sorry, this is the electromagnetic induction. When you cross after atmosphere, the sun emits the radiation at a temperature of about 6,000 degrees Kelvin. Means within the atmosphere, those radiation will be absorbed by the atmospheric molecules. You are safe on the surface of the Earth. Once the satellites leaves this atmosphere of the Earth, if they are traveling either within the space, in the particular orbit of 400 kilometers, the International Space Station, or maybe any of the orbits, geostationary satellites, or maybe any of them actually, certainly they have to undergo electromagnetic induction. Okay. Still, this is the antenna should be tested. Still, these laboratories are there in Bangalore. This is the thermo vacuum, highly vacuum chamber for testing the things for the simulation chamber. They will enclose it with the golden plating to avoid the incoming high radiation, high energetic radiation, because high energetic radiation will be absorbed by the gold plating. This is again spacecraft integration they will do in Bangalore only. ISAC they can call it. Indian Space Application Center. That they have named it as the UR Rao Center. They will take this to the Sriharikota, about 500 kilometers away from us, almost at the coast of next to 100 kilometers away from Chennai in the Bay of Bengal. Bay of Bengal, near to the coastal line of Bay of Bengal. See that this integration part. Then they will close this with the high shielding part. This is a different first stage, second stage, third stage, fourth stage of that kind. This is one of the photography of the Mars I put actually. This is the sun, how it is rotating. Sun emits radiation. This is the wind will come. This solar wind will go even to the extent of the Pluto or Neptune and Pluto. And see here, if any such type of radiation falls on the sensors of a satellite, that gets damaged. Your sensors should be capable of sustaining such high amount of the radiation and also perform properly. We don't know the environment of space environment, either in terms of the radiation or in terms of the energetic particle ACPs they can call, or in terms of the environment, whether they possess the atmosphere or not. These are the gullies and valleys found for Mars, not for the Earth. See that? Okay. The photographies taken for the Mars and the Moon will show this type of features, means similar to that of the Earth actually. You can say that sometime there must be a possibility of the flow of the fluid. This is Olympus Mons they can call, highest mountain in the solar system with a height of about 22.5 kilometers. Mount Everest is hardly about 8 kilometers on Earth. This is the largest Valles Marineris in the solar system they can call. It is having a length of about 4,000 kilometers and wide width of about 200 kilometers and a depth of about 7 kilometers. Grand Canyon on Earth is hardly about 800 kilometers wide, length, and a deep depth of about 1.6 kilometers. Viking 1 and 2 they can call took this picture. Main objective of the Mars mission was one of the main objectives for the Indian mission to Mars is to develop the technology which is required for the designing, planning, and management and operation of an interplanetary mission from one planet to the another planet. Entire technology was built in India. It is an indigenous, they can call. Our own scientists, our own students, our own engineering students, our own scientific community has made that design and realization of the Mars orbiter mission with the capability to survive and perform the earthbound manners. Earthbound manners means if you give a command here, the command should be accepted by a sensor in a satellite and it has to work. If I call, you have to receive the signal. You ask your Majrat Guru sir, he might have called me so many times to fix the talk for you. I missed the call several times, maybe because of the non-availability of the signal, and maybe I am busy and he may be free at some time. And when I call back him, he may be busy and I am unable to connect to him actually. Then how it can be possible actually? If you send a such type of a thing, satellite has to accept. In Bangalore University campus, we are just at the outskirts earlier. Now we are in the middle of the city. We don't have the proper connectivity for the mobile connectivity. Means if a satellite goes or any sensors goes about 75 million kilometers away from us, that should be tracked, and it has traveled 300 days and putting into a particular orbit and then making the study of the Mars. Deep space communications they can call, and in navigation through such a larger distance and mission planning, perfect planning should be done. Even if you leave, if it reaches about few seconds late, bus will be missed. Mars will not wait for the satellite to capture, and satellite will never go in a proper direction unless until it is controlled. How one has to management? Management should be done very pakka. If power goes for 2 days in Mysore, you will not do the experiment. At least during your laboratory classes, if the power goes off, you may not conduct the experiment at all. Then there should be backup for the power. Okay, if it goes for 1 week, can you do your experiments? No. These such type of things are happening. Sorry, happening for the space missions. Then it is a tough task. Another thing is that incorporate autonomous features to handle the contingent situations. Means to say, You started from your home to your college, where in between one of the road gets jammed due to the vehicular activity. You will take another alternative way. There is no doubt. Fine. But if you send a satellite, there are no drivers, there are no controllers in the sense on mission. Satellite has to take its decision whether to move it or not. They will keep the radars, what I told. At a distance of about another 100 kilometers, if some objects are coming, the satellite should be deviated. Such type of things can be taken, decisions can be taken. They will call it as a contingent situation. They have to handle. For example, if some source is coming, some meteorite is coming with so much of high energy, if satellite is moving on en route on the path, along with the path, it will be burned. Sorry, it has to take a deviation. And another scientific objective, not another scientific objective, is to see the explorations of Mars features, morphology, to study the topography, mineralogies which are existing in any of the planets, and atmosphere with the indigenous instrument. After traveling, after traveling 300 days, it entered the Martian atmosphere. How it has to go, you will see that. This one typical representation in such a way. This is towards the Earth, Sun, this is towards the Earth. If satellite is in between, black color, you can see that. Even though it sends a signal, the signal will not be traveled through the Mars and enter the Earth. They will call it as the blackout. Okay. Once it enters here, the signal will be stopped, and the scientists on Earth were worried actually whether we lost the mission or not actually. Okay. Then after crossing that, I will show you one animation here. See that. This is the Mars orbital mission is entering. How they will reduce the speed? Because there are no brakes. If the friction is there, then you can reduce the speed of a vehicle. What normally they will do? They will call it as a booster. Boosters are the one where they can change the direction of the spacecraft. Actually, see that it rotates 180 degrees out of the pitch. See that. Then they reverse boost. It gets slowed down. This is the blackout region they can call. Once it is coming out of that, still you can get it. I will replay it only for your case. See that it comes. Comes. Reverse, slow down. This is the blackout region they can call. Firing has started. Mars occultation entry they can call. Occultation eclipse exit means signal has to travel. It will take 11 minutes for the signal to travel one side for 75 million kilometers, even though it moves with a speed of about 3 lakh kilometers per second. Okay, you just work out from the velocity is equal to lambda, sorry, c is equal to speed of light is equal to what they can call distance, velocity is equal to distance per time, sorry, velocity is equal to distance per time, or distance, you know that actually time you want, time is equal to distance per velocity. Distance is 75 millikilometer. Light has to travel the same electromagnetic signal has to travel 3 lakh kilometer per second. It takes 11 minutes at one time, and to come back another 11 minutes, 22 minutes. Even though you are getting a real image on real time or real information on real time, a delay of about 22 minutes will be there. Mom successfully enters the Martian orbit. There are 4 stations. Sorry. One is at Goldstone, Madrid, Bangalore, Bailalo they can call. Those who are near to the Bangalore might have seen the Bailalo, might have seen one great thing, and Canberra. Because if the satellite is on opposite side of the Earth, actually, we may not receive the signal at all. That is why 4 stations will receive the signal always, and the signal will be transferred to the server, which is maintained by any of the country, preferably for space studies. Okay, India also has having a collaboration with other stations, and other countries, even including NASA, also is having a collaboration with India to receive this type of signal. This is the Bailalo here. Sorry, 32 meter is the diameter of this antenna. You might have seen on your house where you might have receiving the signal, particularly for your TV channels, D2H, direct to home. The diameter of antenna may be hardly about less than a meter, about half a meter they can call. This is about 32 meter. This 32-meter antenna has to sustain the heavy wind speed and other part. It should not go corrode, and it has to receive the signal. Okay, this is the first picture with a spatial resolution of about 376 meter. The image was taken from 7,300 kilometer away from the Mars. See that this is the entire picture they have taken at a distance of about 75,000 kilometer. You try to take a picture of your nearest object from your mobile camera, hardly about 2 kilometers. If you take the picture, you may not see the features at all. Still, the camera is good enough. This is the valley they can call, one of the Great Valley. Mars seen from the altitude of about 8,500 kilometers roughly. Mars color camera can call. Color means it represents. This is another image with the mountains and other things. With about 66,000 kilometers away from the Mars. Moving camera is also moving, planet is also moving. This is the three-dimensional view. See that craters have recorded for the, this is not on Earth, don't get confusion. This is for the Mars actually. Okay, 3.8 kilometers is the depth, 4.8 kilometers is the depth or thickness they can call. This is the 5 kilometer depth. This is the Chamas they can call. This is for the thing. Another one. Finally, India achieved. All countries have accepted that the India has had the capability of entering into other planets with planet missions. In the beginning, okay, fine. This is the Sriharikota region where they used to launch the satellites. Almost 120 to 130 meters is the height actually. See the dimension. 2 launch pads are there, first launch pad and second launch pad. Both they will use one after the other. ISRO is sending a satellite almost like a city bus from your central bus stop to your JSS institution. This is for the Chandrayana, what they have played, rover, Vikram, and lander, and the other satellite. These are the pictures for the Chandrayana-2. See that this is the Jackson crater with about 71 kilometer diameter. This is the Mira, March, Jackson. This is the same image. Same image here. How they will take the image? This is the part of the image. They will enlarge it. Then they will combine. This is the enlarged image, how it looks. Always it will never be color. Color. It is the composite they can call. Composite means overlapping of several images at a time, how it looks. Yeah, I proposed putting a satellite into the orbit, but I mentioned as a preamble so many things. Our purpose is that right now I will bring the physics, everywhere physics is there, so far also. What is an orbit? Orbit is a region where you can encircle one of the fixed orbit or object you can call. If you throw a ball from the top of a mountain, the ball will fall down by making some trajectory, maybe the first trajectory. If you throw very forcefully, maybe the second. If you throw further, maybe third. Is it true? Yes, there is no doubt out of it. Maybe if you allow the ball to live without the force, simply it has to fall down near to your foot. Otherwise, you throw it, it has to be. Both balls hit at the same time. Assume that is a height of about 1 meter. This is also height of 1 meter. Both balls will hit. Even if it travels about 5 meter, even if it travels 1 meter. That is the acceleration. And they have to move with a speed or the acceleration, sorry, they can call, with about 9.8 meters per second square. What happens? I showed the same thing here. One will trajectory here. Second, maybe a circular object orbit. Third one, maybe an elliptical orbit. Fourth one, maybe a parabola. It will never come back. Maybe, this one, third one. Fourth one. Then this may be in hyperbola. It will escape from the Earth's gravitational influence. This will also maybe encircle like as a parabola, but it will never come back. Oh, means even if you throw either for everything, 8 kilometers is the horizontal distance, 5 kilometers is the vertical distance, you will get the linearity. For every 8 kilometers straight line, if you draw, this line will never touch. The Earth is spherical actually. For every 5 kilometer distance, you will get an obliqueness. Earth is curvature. So an object in the Earth orbit literally falling around the Earth, but because of its horizontal velocity, it never quite hits the ground. This is the phenomena how we are expecting. Because of this, for example, here if you throw, the person will catch. What you practice actually, what you practice if you are playing a game with your kids actually, the elder one will throw the ball. If the younger one wants to catch, of course, she can catch the ball wherever the ball comes. She has to estimate the speed, what speed it has to come, not in terms of numerical value, it is by guess, where it has to fall. Wherever the ball has to come, she has to go that direction and she has to hold it. But thing is that for the kids, what normally they will do, to build the pitching ball, they can call, or maybe batting cage, or even to launch a spacecraft into the orbit, we can't simply tell the mission or the rocket to take the aim and throw the ball. What normally they will do? The elder one throws the ball in such a way, younger girl, maybe sister, or maybe best friend of her, has to catch the ball. What she will do? She will throw the ball in such a way, to her, she will hold. She will never throw the ball across, where she will miss catching the ball. But thing is that the same thing will happen with the satellites also. For that, we have to define the coordinate system. We have to derive an equation of motion. We have to apply the assumptions. The assumptions should be simplified assumptions. And we have to assign the initial coordinate systems and initial conditions also, how much speed it has to go. And we have also perform the error analysis. If we miss this error analysis, it will never. We have to test the model. The model in the sense, we have to test the concept, whether it works it or not on the Earth. Being this is the reference point, throw it, it will pass the trajectory, it has to hit. Every point, you have to solve the equations of the motion, and you have to solve within the initial condition and the final conditions, where it has to take the derivative. Here at the top, the velocity should be 0, maximum velocity. It may be come to a rest for a momentary of time, then it has to fall. Okay. I will not go. Maybe I might have taken enough time. I feel that. Being this, gravitation coming to the picture. Now, this is those two earlier for the Earth actually. If you want to leave the gravitation, first of all, you need to define the frame of the reference and the coordinate system, either Cartesian coordinate system or maybe in some other kind of a coordinate system, maybe an elliptical or horizontal coordinate system of that kind. Once it is determined, you have to work out. Once it is reached, it will always all the objects. Moon is under the gravitational influence of the Earth. Earth is under the gravitational influence of the Moon. Put together, both are mutually attracting each other. Both systems are under the gravitational influence of the Sun alone. If you are removing Moon, not physically, by model, Earth will never be at the 150 million kilometer from the Sun. It has to move relatively away from its trajectory. Certainly, life on Earth is a tough task. We are at 150 million kilometer, even by the virtue of the great planet Jupiter. Jupiter also attracts, Sun also attracts. Between the two attractive forces, the Earth is kept perfectly at about 150 million kilometer, need not be exact, even though it is following an elliptical orbit of about 147 million kilometer nearest to the Sun at some time, and about 153 million kilometer away from the Sun, and making the two seasons like winter and summer. And in between, because of the tilt of the Earth, we are having the spring and rainy season to a great extent. Means central force has to attract, okay, where we can keep the planet or any natural satellite into the perfect orbit in elliptical orbit. For the two forces, what you are studying so far, or what you studied and studying, the gravitational force of attraction is the universal law corresponding to the gravitational potential energy, how that the two massive bodies get out. Preferably, they can use the uppercase of M for the heavier mass and the projectile as the lighter mass of that kind. What is central force? This is the force which can attract the other objects together. This is the defining. I can share you the PPT also later. Means spring constant also you are working. That works with the same thing. Spring constant of the half kx r square is the energy which is required to keep the object. Okay, maybe some pendulum experiments you might have done in your physics laboratory. I'm sure out of it actually. They are all the central force fields. Earth is attracted towards the sun is also central force field. Moon attracts towards the Earth is also central force field. Satellites attracts towards the satellites are nothing but an artificial objects which are put under the gravitational influence of any of the planets together. Coulomb force also plays the same thing. Means between the two charges you can expect the central force. In all these cases, the force is along the direction of line joining here, joining the center of the source point and the probe object. Can work out the orbital angular momentum, how it should be the r cross times t. This is the distance of separation. Angular velocity is very much required. Okay, means central force problems are essential to understand the two-dimensional movement of the objects in any of the plane. All the discussions what we made, actually central forces is fixed in one position, maybe the sun or maybe the earth for the satellites. What if the source of the object is also in motion? Both earth is moving, satellites are also moving, sun is also moving. If it is accelerating, then it defines a non-inertial frame, means where the Newton's laws are not valid to extent, used in that context to see the phenomena. If so, proceed to tackle the more general solution or situation they can call two-body problems involving two dynamical objects, both moving around, pulling on each other through a force that lies along the line that joins their correction centers. You can work out, even you want to solve some problems, particularly on carbon monoxide molecule as a diatomic molecule in expecting the reduced mass, okay, with the common center of mass. Objects has to move. Center of mass of the two body systems drifts through the space with constant momentum and constant velocity. That is how we in a sense, both Earth and the natural satellite Moon are tightly bound to the sun. The satellites of particular artificial natural satellites are bound to the Earth by this relation, actually. See that? This is how it happens. The same description I wrote, actually. Sorry, I might have taken a little bit long time. Sir, another five to 6 minutes. This is a bound system. See that? Need not encircle each other. See that? They will never collide. If we are in a regime where the source of mass is much heavier than the mass probe, like sun, in such a scenario, the source mass is too heavy to be affected by the solar mass and essentially stays to put it into the particular object, orbit they can call. Then theory of relativity of Einstein will come into the picture. All objects has to follow the gravitational force, universal gravitational force. See that? How it is done. We are at about 1 astronomical unit, that is 150 million kilometer. This is the Earth. Moon is gravity. Nearest point is known as perigee. Farther point is known as the apogee. 147 million kilometer. 152 million kilometers where it is far away. Both will play into a picture. Of course, different orbits, what I told earlier, maybe circular orbit, elliptical orbit, parabolic orbit. Para and hyperbola will never come into the picture. Parabola will happen for the Halley comet. Halley comet is having a periodicity of about 75 years. If you live for 75 years, at least you can see in your lifetime once. Okay. Means sun and the Earth, actually, they are in elliptical orbit. Sun will be at the one of the foci. A great mathematics will also come into the picture, and all great mathematical work will link with the physics, where you will become a scientist for the planetary science or the space science too together. Orbital mechanics makes a very much important role. Copernicus was one of the great scientists who worked between 1473 to about 1543. Mentioned about sun-centric, where all planets are revolving around the sun. And these are the fixed stars. Three great scientists, Newton, Kepler, and Tycho Brahe, they can call the inventor. This is one law, this is the universal gravitation. Force is equal to m1 times m2 over r square. This is valid for all the massive objects across the universe. Kepler's law also, three laws are there. They give the trajectory. See that. One of the orbit of each planet is an ellipse. There is no doubt. With the sun at one of the foci. Okay. This is the major axis and minor. And second law is that the Earth sweeps equal amount of area and equal interval of time. For example, this is for January, this is for April, this is for the August. Means it has to cover the same area in all the months. Not 31 days or 30 days of that kind. Equal amount means if you take 30 days month, for April, and maybe in September, or maybe in another month, it has to cover the same area. Third law says that the square of the periodicity of a planet is proportional to the cube of its mean distance from the sun. Mean distance from here, this is focus. This is the mean distance from the sun. If you take, it has to move. Means by seeing that, one can able. In fact, the orbital elements can be defined as in terms of the major axis, eccentricity value, inclination of the planet, or argument periapsis, right extension they can call to anomaly. These are some elements. Of course, if you may not have touched upon right now for your graduation, if we are in post-graduation, certainly they will do that. All these links with the classical mechanics only, don't come with the space physics. If you have studied your classical mechanics well, if you have studied your electrodynamics well, if you have studied your all properties of the mechanics well, if you know the rules, certainly you will be a planetary scientist in future. Again, the circle, ellipse, parabola, how that radius, major, semi-major axis will be there, or how that eccentricity will be there. Inclination also makes, because you can't put the satellite wherever you want. If you want to see whether polar region or equatorial region, this is very much required. True anomaly, if it moves away from that, how it can be controlled. See that. Take these things. If you cut at the top, it becomes circle. If you cut at here, this is ellipse. If you cut at here, it becomes parabola. If you cut here, it becomes hyperbola. Same cylindrical cone. Maybe you can practice like a sheet of a white paper or some material of that kind. If you cut 4 sheets, you can make. If you cut here, it becomes circle. Here with inclined elliptical orbit, parabola, it will never come. Only the comets will do that. This is hyperbola. It will never come into the picture. Isaac Newton told the planets move one and the same way on the observations of the concentric. Some are irregularly, it is accepted, which may have the horizon from the mutual actions of the planets upon another, and which will be apt to increase till the system wants to reformation. Actually, this is a fixed rate. This is the dynamical things, how it can be there. See that this is the Iowa is one of the satellites for Iowa, Europa, Callisto, Ganymede for the satellites for the Jupiter. Jupiter is having the largest number of these satellites. What I told is that this is how that orbits can did not be putting into an orbit of 2,000 kilometer, 5,000 kilometer, about 20,000 kilometer for the communication satellites, or 36,000 kilometer for geostationary satellites. These are the orbits actually. In fact, this is the yellow color is for the Halley comet. This is the circular elliptical orbit. This is the circular, more or less. This is the parabolic. Still, these are the things. See that two-body problem has to work out. There is no other way to go. Kepler's laws will come into the picture in finding the position of an orbit of any of the satellites, any of the planets I can call. It sweeps of the equal amount of the area in equal interval of time. Newton's laws, association, universal laws of universal law of gravitation and Newton's laws makes the satellites to put into the desired orbits. Kepler came into the picture. See that where the hell did all the dust has come from? This is the dust what you are expecting. You are grooming your surrounding areas every day because dust is entered into your room. But at the same time, where the hell did all the dust is coming? This dust means cosmic dust they can call. Planet is also cosmic dust. Another star is also cosmic dust. Another Andromeda galaxy is also cosmic dust. Okay, scientists working in their own laboratory will think like that. Kepler's first law, second law, third laws, rules. These are the laws actually, rules the planetary motion. This is a mathematical review, just I expected. Another case, elliptical and orbits exist. First law, you can expect sun at one of the foci. This is actual center. They have to follow the elliptical orbit. Mercury is the 0.21. The Earth is about 0.18. And the Halley comet is having highly eccentric, about almost 0.97. Orbital angular momentum is the one with radius vector with the angular momentum, what it can expect. Should be the constant for all. Being this constant, Kepler's law says that square of the t square must be equal to r cube. One can able to estimate that either the time of, or that is time is periodicity of the planets, or the position of the planets. See, this is the one beautiful table. You can also work out from your lab. If you know mass, if you know the distance, you can estimate the periodicity at any amount of time. By knowing T square by R cube must be constant for all, starting from Mercury till to the extent of the Pluto, they are the constant. This value is constant, T square by R cube is constant. If you know the T value, is how is the periodicity, you can estimate the value. That is how earlier days, the scientists have identified the position of different planets before they are reaching the rest. Even you can have the weight of the sun also by the simple mass rule. Mass of the earth, you know. Periodicity of the earth, you know. Radius of the orbit of the earth from the sun, you know. You can estimate the speed that should be have 3 into 10 to the power 4 meter per second, orbital speed. Gravitational force, you know that here. Just equate them two together. You can estimate the mass of the sun should be 3.3 into 10 to the power of, 2 into 10 to the power of 30 kilogram. Or you can put almost 3 lakh equal to 3.3 times the 3.3 into 10 to the power 5 times the mass of the earth. In the sense, to counterbalance the mass of the sun, you have to put almost 3 lakh earth into another planet. Newton came, he gave the Newton's law of gravitation with the simple relation of F is equal to mA or W is equal to mg. You equate them together, you'll get the acceleration that should be equal to v square by r. Or you equate this F is equal to mA and also mv square by r, what you will get the universal gravitation law. I hope physics teachers and also maybe Manjunath Guru might have taught you in your class. This is a basic law. Being this, Coulomb force should be equal to the gravitational force. These two, if you equate it, you'll get the expression for the velocity of a planet or a satellite to revolve around the fixed orbit. 2 pi times r over t should be the same. Flying pig, you can expect, you can rotate actually here. Okay, you can estimate the speed, or you can also estimate the time parameter. One can also estimate what must be the ratio for r cube by t square for the sun. Like that. That is the how people have thought of putting a satellite into a perfect orbit known as geosynchronous orbit. Means a satellite should have a synchronization with the speed of the earth. Okay, see that. If it revolves, what will happen? G should be, you can estimate the value of the G in both the cases, how to find the G at a distance greater than the earth's surface. Velocity also you can find square root of the RG. These are all the physics principles. At the surface, it's about 8 km per second. Now we are moving with about 8 km per second. We are on surface of the earth. If it is at about 36,000 km, certainly it should be about 22,300 miles above the earth's surface. Can use this for the planets also while estimating the law. These orbits will come. This is known as heliospheric orbit. First, let us start with the LEO. This low Earth orbit. Almost all satellites which are capturing the image of the Earth will revolve here. This is the medium Earth orbit satellite. Sorry, this LEO is somewhere here. Okay. Medium Earth orbit satellite about 5,000 to 10,000 km. Geo is the geostationary orbit about 36,000 km. And this is the highly elliptical orbit of that kind. The same thing I have shown in different orbits. This is the one where the speed should be less than the critical velocity. Velocity should be equal to the critical velocity. Velocity should be greater than between the critical velocity. This is for the parabola. This is for the hyperbola. Kepler, Newton, and Kepler's laws, Newton's laws of universal gravitation, and Newton's laws. These three laws are very much essential. The same thing here I worked out. Newton's law of gravitation you can work out with the same thing to put the object into an area where mass of the object is not required. Okay, that is ignored. You can go for the elliptical orbit. Okay, we'll see that with all these things, what is the purpose actually? What we are getting out of it actually? That's very important. Okay, in physics you might have studied so many laws and putting the objects into the particular orbit. What is the purpose? ISRO's Apple satellite was carried on a bullock cart. There's no doubt, for an antenna testing and also for range test. ISRO was established 8 years after Pakistan Superco. ISRO launched more than 65 satellites, I can say. Not 104 satellites are put together. Okay, no, 65 missions they can call, where Pakistan has launched only the 2. In the sense, nothing to compare with Pakistan or neighboring country, where the scientific activities in India has gone beyond our expectations. Okay, Nothing is working in your lab will work for the satellites in this space. Means to say the technology, whatever it was achieved indigenously, has to make it work. There is no other way. ISRO's expenditure, if you expect, budget of the ISRO, if we are expecting, 40 years of the budget of ISRO is equal to 1 year's budget of NASA. Means they are spending lavishly. If you buy an IC of 2 rupees, if you buy an IC of about 2,000 rupees, the performance is not the same. Not in terms of budget, what I need to say. If you are buying a mobile handset of about some 5 to 6,000 rupees, and if you are having an high-end mobile of about Apple, about 40,000 rupees, the function differs, lifetime differs, accuracy differs, not in terms of money. The components used for such type of things will differ. Still, ISRO's budget, 1 year budget, 40 years budget is equal to 1 year budget of the NASA, but even with that, we are capable of. ISRO has built about 104 satellites with 1,378 kilogram of payload, still we achieved. That is why neighboring countries or some of the economically weaker countries are sending their satellites to us to launch for their purpose. ISRO also making money out of it. IRO, R is replaced by the rupee symbol. To launch a satellite of about 1 kilogram, it requires $30,000. You estimate. To launch a satellite of 1 kilogram payload, 1 kilogram, $30,000 it requires. With that, Chandrayaan, India, the 4th country to place a flag on the moon, no doubt out of it. Even though there are some controversies with the Armada, who has landed on the moon. ISRO also sent a satellite to the Mars, making India the first country to do successful in its attempt. Particularly, the time will come when man will know when even what's going on the other planet and perhaps be able to visit them. In the sense, the time will come when man will know even what's going on the other planets like Mars or Jupiter or other planets. You might have studied it. Just Google it actually. What is the atmosphere of the Venus? What is the atmosphere of the Saturn? What is the atmosphere of the Neptune? Do you think that the people might have gone there and measured the temperature, measured the pressure, or might have gone there and taken the photography, how it looks actually? Still you know that. The time will come on the other planets and perhaps be able to visit them also. It is sure. Scientific community, not scientific, people have landed on Mars, not landed, about to land on Mars, landed on Moon. ಇತರ ಗ್ರಹಗಳಲ್ಲಿ ಏನು ನಡೆಯುತ್ತದೆ ಎಂಬುದನ್ನು ಮನುಷ್ಯ ತಿಳಿದುಕೊಳ್ಳುವಂತಹ ಸಮಯ ಬಂದೇ ಬರುತ್ತೆ. ಬಹುಶಃ ಆ ಗ್ರಹದಲ್ಲೂ ಕೂಡ ಇಳಿಯೋದಕ್ಕೆ ಸಾಧ್ಯ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿ ಯೋಚನೆ ಮಾಡಿದ್ರು. As far as this is, Aditya, it got postponed due to the COVID. We launched soon. Gaganyaan, still it is under planning. Chandrayaan 3, sorry, again got postponed for 23. Mangalyaan 2 is already over. Okay, 3rd we are planning. This is a Sukrakanya to study the Venus and other thing. It is planned between 23 and 25 for Indian ISRO side and Indian Space Station. Humanoid, a beautiful lady with a computerized human body, they can call. It is also planned. It will go very soon in 2022. If we are using it for good cause, it is the human mission, fine. If it is for inhuman missions, we will be barred behind the child. Thank you. Thank you for your patience. Thanks for all for making my time to have a discussions with you. Any queries? I'm very happy to take it up right now. I will stop my presentation.
Thank you, sir.
You can communicate to me through email also if you want.
Yes. Definitely will provide to our students, sir. Thank you very much, sir. It was wonderful to hear to you, and it was almost actually it takes a lot of time. And I thought we would have done 2 sessions for your seminar, your webinar only, your talk only.
Okay,
it was very good, sir. Such a one query from my side, from student side only. So thinking how to enter to ISRO is after completing masters in physics. Is there any entrance? That will be a common question for all students. Even I was having that doubt when I was studying. So I wanted to ask the same questions to you, sir.
To enter any of the institutions, graduation is not sufficient now. You should have a master degree with good understanding in science. Science, we are saying in a broad umbrella, need not be physicists alone. ISRO employs physicists, chemists, mathematicians, computer engineers, Computer engineers need not be only the people who are working on a computer, where they have an understanding and capable of doing some tasks. They will have a entrance examinations. They will advertise for the posts actually, and you have to qualify through the entrance. And another thing is that if you are performing a PhD, there are more easier ways to enter any of the R&D labs with PhD program rather than master degree alone. It's a time limitations. There is no other way, because you should show your skills. It is not an ordinary job of selling in either vegetables or grocery or something to the vendor where your limited knowledge is required actually. To do this, it requires much of understanding in physics and computational skills and also an electronic part of it. Of course, you can join in any capacity, even as a chemist also to a great extent. They will conduct, right now also they have advertised for about some 30 odd research fellowships, and every year they will advertise for the manpower. Maybe due to COVID, from last 1 year, the appointment might have reduced in terms of the number. Certainly they will take it up.
Thank you, sir. Actually, why I ask this, there are students from master degree also.
Yeah, that's true. I'm saying that. See, unless you show your skills, even to enter, they might have entered your institution, JS institutions as a students right now. How they can enter your institutions as an employee? They can join you as some typist, or even as a clerk, as a principal, or as a professor, as a teaching faculty. Like that, it will be there. Okay, that depends on their interest. Right now, they may be asking in terms of their research part, I hope actually. Because ISRO is a scientific organization. Baba Atomic Research Organization is also a scientific organization. Department of Atomic Energy is also a scientific organization. Those organizations also having a staff for administration. If you want to become a director for that, you clear your IAS or something like that, you can join. That is another caliber actually, what they can call. From science background, they can join there as a staff, scientific staff. They have to have minimum of master degree. With graduations, they will take only for as an observationist, or only for maintenance of some lab, they will take as a research assistants, but not at the level of the faculty members.
Thank you, sir. It was good. It was good hearing to you, sir. Is any other queries from sir?
Manjunath Guru, sir, still is there?
No, just now he went to.
Okay, no issue, no issue.
Principal. Yeah. Okay. So then I thank the speakers, the second resource person. He was wonderful. As I told, we would have done 2 or 3 sessions of same. So he has done such a wonderful talk on his topic. So now I will propose a vote of thanks actually. Is there any other queries? I will let the students to ask any queries, or else you can email to us such that we will forward that to same to sir. So I think there is nothing there. So I'll just propose my vote of thanks now. At the outset, I offer my respectful pranam to Guru Parampara of Shri Suttur Mutt. I would like to thank JSS Mahavidyapita for making this event happen. I also thank both the resource person, Dr. K.M. Ishwarappa sir and Dr. Kamsali Nagaraj sir, for their valuable time and resource shared with us. Thank you both, sir. Thank you, sir. Thank you both, Ishwarappa sir and Kamsali Nagaraj sir. I thank Professor Sambashiva sir, the Chief Executive of the college, and Dr. H.C. Vannappa sir, Principal of our college, for their efforts in conducting this webinar. I also thank Dr. Vijay Manjunath Guru sir and Dr. Vinay Kumar L sir, who were the instrumental in organizing this webinar. I thanks to Karthik sir and the support staff and our students for actively participating in this webinar. I thank one and all for being in this webinar. Thank you all. Thank you, sir.
Thank you. We'll exit. We'll leave them.
Yes, sir.
Thank you.
Very exit.
ನೀವು